The classical is cherry, that's strawberry. I said strawberry. I just
Hello, Anna.
can't find anyone.
Good morning. Do you hear me? Do you continue?
Small, it's called Berliner. And I'm Berliner. Yeah, she wanted to be nice, but
Anna, good morning.
Good morning.
Can you just try to share your screen?
Yes.
Yeah.
Okay, can you see it?
Yeah, we can see it.
Perfect.
Perfect. We can hear you, we can see you, and we can see your presentation.
Good.
So we'll start in a couple of minutes. Everybody. Yeah, just a moment.
Dear colleagues, so I want to introduce my colleague from Spain. It's Anna Castaneda, project manager of Iron Company, Spain. Anna, please.
Hey, thank you, Andre. So good morning to everybody. So as Andre told me, my name is Ana Castañeda. I'm from IDOM, a Spanish engineering company. So in this session, we are going to present the project management principle and phases for construction, especially for the nuclear power plants. So I will present myself a little bit. So I'm industrial engineer with more than 19 years of experience, 10 of them already in the nuclear sector. I'm doing project management. I'm currently based in ITER, in the ITER project in France. So we are having a role of support to the owner for the European domestic agency. So doing management and tasks. So this presentation of today maybe is going to have a lot of information, very concentrated, because we wanted to go through all the concepts of the project management. At the end of the session, there will be some minutes for question, but nevertheless, don't hesitate to stop me, make me question, as long as we are discussing and presenting things. I will start with a very short introduction of IDOM. As I said before, it's a Spanish engineering. We are based in Spain, and the headquarters are in Bilbao. So we have more than 60 years of existence, working all over the world in more than 120 countries, with 45 offices in different countries as well. So we are more than 4,000 people. Important to say that we are an independent professional services company. So that means that the company belongs to the people of the company. So we are more than 800 partners in the company. That's allow us to make our own decisions. So we don't depend on a big company or a bank or financial or some vendors. So we really choose our projects, and we go and we accompany our clients where they want to go. We are structuring 4 main technical areas: architecture and building, infrastructure, consulting and system. And in particular, the non-nuclear services is in the area of industry and energy, that a part of the rest of standard generation, thermal generation, or manufacturing, or renewables, or oil and gas. Also, we work in the nuclear sector. Going more in details in the nuclear, so in IDOM we are more than 400 people that have been involved, or we are involved in the nuclear projects. We have been participating in a big number of projects, more than 300, with 40 years of experience. So we can say that we are well positioned in the nuclear sector engineering. Now we are going to start with the session in particular. So as we said, with the project management principle and phases. We will start with some concepts regarding contracting strategy, because when we think about starting or to build a new project, we have to start from the beginning, starting on how we want to organize everything, how will be our strategy of contracting the engineering, the contractors, who is going to do what, when and how. So some concepts for this. The first one, very important. Maybe sometimes we don't pay so much attention to this concept of the stakeholders, especially in the nuclear sector. We have a lot of stakeholders. So what is a stakeholder? So it's any organization or any people whose interest may be positive or negative impacted by the project. And also the project can be impacted by them. So they have influence in the project. And a stakeholder is not only the utility or the owner, it's not only the contractor. So we have a lot of stakeholders that can influence the project. So for example, we can have the government, depending the policy regarding energy in a country. Sometimes even they can be financing some of the projects, so they are a stakeholder. They have a lot of influence, especially at the beginning of a project. We have the country itself, so we cannot forget that. I mean, the country acting to, especially towards nuclear energy, can have also a very important influence. So, for example, just for to let you know, here in the project that we are doing here in ITER, so every year there are a couple of open day sessions, and also a lot of information shared with the people, especially the villages and cities close to the project, explaining the benefits of the fusion energy. People need to understand what we are doing, so they have also this influence for sure. I would say the owner, the utility at the end, the contractor, but also the safety authorities. national or international, so the IAEA, so the national with all the standards and rules of the country. So we need to take care. They can be constraints for us. We cannot forget the market. At the end, we are developing a nuclear power plant to get some energy that is going to be consumed by someone. So we cannot forget at the end who will be the clients, the last clients. If we need to get some financial, also the financial entities or export credit agencies are also very important stakeholders. Vendors, for sure. We need to select the vendors for our reactors, our components, so they can influence as well. And without forgetting at the end of the life cycle of the project, the waste management. So we need to think about them at the very beginning as well of the project. So all these people can be a stakeholder, and the management of the stakeholders will be very important. We will see later on. When we are thinking about how we are going to organize all the project, we need to think in a top-level contracting strategy. So, from the very beginning, the preliminary engineering studies, surveys, the infrastructure, where we can do it, we cannot do it, we are going to get the license or not. So these are the very first stage. But then for all the contract that we are going to put in place from the contractor, we will see different type of contracts to put in place. The contract with the fuel supplier, we will need them. Operation and maintenance, once the project has finished, we have done the commissioning and we start to operate, we have to have this contract put in place. And as we said before, on the back end, so we need to manage the roadways and the spent nuclear fuel as well. So we have to think about the whole picture at the very beginning to think about the strategy. When we think about the strategy and the different contracts to put in place, we also have to have in mind the different price strategy that we can have with each one of these contractors. Not all the contract has to have the same kind of pricing strategy. We need to adapt them for the needs and depending what we are doing. So we can have three main groups of pricing strategy. Fixed price, also known as lump sum. So the contractor, imagine that we are the owner. We want to make a contract that we say, okay, these are the requirements. The seller has to study them and they will give us a complete close price. This has a lot of risk for the one that is selling, for the contractor, for example, and less risk for the buyer because you have your close price and then all the risk in the contractor part. Then we can have several kind of modalities inside the fixed price, just a fixed price and that's all. Then we can have some incentive, for example, if we comply with some milestone, for example, to finish the civil work in one date. Maybe there will be an incentive, so you will get more money if you comply with this milestone. And then also there can be some kind of price adjustment depending the situation or depending the volume that we are going to do. On the other side of the fixed price, we have the cost reimbursement. What does it mean? That at the end, the contractor is very comfortable in this situation because they will, let's say, charge and they will be paid, but really the work that they have done. So the people that has work and the cost of everything they have subcontracted, for example. So they will present the invoices of what they have spent, and then the client will pay for this plus normally a profit on top of this. So, but the risk for the owner is that they don't know really what will be the final cost of their project. So, and then we have something in intermediate, like time and materials, that is that a contract that you have a lot of scheduler rates in the contract with prices for a manager, prices of a designer, prices of a worker, prices of all the materials, can be concrete, can be a system, can be the reactor. So depending then really how many people has worked and how much material they have used, they will be paid for this. So this is an intermediate situation between the fixed price and the cost reimbursement. Advantages and advantages. So with the fixed price, mainly the client only have to fix some requirements. With the cost reimbursement or even time and material, the client need to do a lot of work before putting the contract in place, because maybe have to done measurements, bill of quantities, an estimation of prices to know where they could be. So this figure represent this, the cost reimbursement and the fixed price, with the risk for the owner, risk decreasing from the contractor, and the flexibility. I didn't mention that, but when we have a fixed price, we are fixing the requirement at the beginning of the contract. So then we have very little flexibility to make changes in the opposite side. So we can be defining the project little by little, including new requirements, making changes, because at the end, okay, we are going to pay for really what is done. So in the strategy, we need to think, depending on our contract and our needs, what could be the better strategy. For example, if we have very clear our requirement, because it's going to be a replication of a 16 project, maybe we can go to a fixed price because we know the requirement, we know lesson lengths, we know what we want. It's clear we can go in this direction. Is we are going, for example, like in ITER, in an experimental project. So there is a lot of things that we don't know today. We don't know the cost because they are new technologies. So maybe we have to go to another type of contract more than cost and reinforcement. The requirements are going to be known as long as we are doing design. So it's very difficult to know them and to have a fixed price. It's not going to be fair for the contractor, and it's really risky as well for the owner. More things to have in mind, apart of the stakeholder, the main contract, how we're going to do the pricing strategy. Then we need to think, okay, we have a very big project. So what are we going to do? We are going to just have one main contractor to do everything. We want to do a little small pieces of contract, doing a breakdown of all the scope and giving a contract to each different companies. So as before, each thing has positive and negative point that has to be thought and adapted to our contract. So we can go with a turnkey contract. It's only one single contractor. Why no? Normally it's happened a lot in big contract that it's not only a single contractor. Normally it's a consortium or a joint venture of 2-3 main contractors. They will be responsible of doing everything, responsible of doing design, doing construction, doing procurement, commissioning, and they will be responsible of the whole plant completely. So here the role of the owner is more than supervision or oversee that really the contractor, the main contractor, is complying with the requirement and the scope that we want. But all the management, all the coordination, all the design, all the responsibility are under the turnkey contractor. So normally this kind of contract is linked and is based with a lump sum contract, because we are giving them the requirement. It's up to them then to deal with everything. The IAEA also have another way of making packages that is called split packages. But this split, we are doing several contracts, not too much, maximum 5, 2, 3. Maybe we can split in nuclear island and turbine island, only 2 contractors, or 3 contractors. Also, when there's another one doing the civil works, or 5 packages for the nuclear, the turbine island, civil works, another for electrical, another for all the mechanical facilities. In this case, now the role of the owner starts to increase. We have a little bit of coordination. We have interfaces. We have interfaces between civil work and all the system. So someone has to share this information from the one to the other. The coordination, the interfaces, they start to have and to be important workload in the owner part, and responsibility as well, because the company doing civil work, if they don't know the mechanical or the system, they will receive input data. But if this input data are wrong and we have a mistake, They are not responsible. The responsible will be the owner who is taking the input data and giving to them. And then if we go to the other extreme, so we have the multi-contract, so a big number of contracts, small pieces. We can just, for example, divide by different buildings in the plant, different system inside in each building. This requires for sure the owner to have a project manager consultancy to help them, because normally also the design is done by the owner, by an architect engineer, or one of the contracts that they can put in place is only to do engineering, and all the responsibilities in the owner side. Again, depending the strategy, our global strategy also it has to be thought. Talking about these responsibilities, for example, we can see, I don't know, just to choose one, project engineering. So we have a turnkey contract, so the responsible of the main is for the main contractor. If we have a split packages, as I mentioned before, so the design maybe is done by the architect engineer or directly by the owner, and also with the support of the system supplier, taking their input data. So he's here. And if you have multi-contract, normally it's directly the architect engineer or the owner who is doing all the design. Then if we go to manufacturing, for example, again, the responsibility of all the manufacturing is the main contractor. If we are in a turnkey, if we are in multi-contract, it's directly the equipment manufacturer. So as you can see in a turnkey, most of the responsibility are in the main contractor. If we are in a split package or multi-contract, so the responsibility is going more to the owner or to the architect engineer. At the end is another contract put in place by the owner and supporting the owner to do this part. Also, this will depend about, imagine that you are an owner, so it will depend if you have resources internal, or you can do this type of work, or if you don't have it, or you don't have the knowledge, you need to hire someone to do all this work. So the less knowledge and resources that you have as an owner, maybe you are going more in a direction of a turnkey contract. If you have this knowledge and the resources, or you can have an architect engineer or a project management consultancy, you can go for a multi-contract. Another advantage of multi-contract, for example, if we are, coming back to this slide. So as we are doing contract by really small pieces of the project, we can have the best specialists in civil work. We can have the best specialists in the system. This maybe will be even cheaper. So because we are doing small pieces, we are doing a lot of different call for tenders, choosing the best one technically and compliant with the budget and the schedule. So maybe we can have better specialists here, because in the token will be a main contractor, then they will subcontract maybe this specialist, but we will not have the control of the specialist. In this case, the owner can choose, let's say, one by one what they want to have, with the disadvantage of all the coordination and the responsibility. So we are entering now in the phases of design. So what we call project life cycle. At the end, the project life cycle is more just at the different phases of the design, from the very beginning to the end. For example, the PMP define this project life cycle in phases like initiating, planning at the beginning, executing, monitoring and control, and then closing the project, which is something that we normally overestimate. So starting, for example, for the front-end loading. So the front-end loading is the definition of the conceptual design, the basic design, what we want to do. Then we have the construction phase. Then we have operation and maintenance. And we cannot forget in the nuclear sector, very important, the decommissioning and the dismantling phase. So for this is all the life cycle of a nuclear power plant project. So then there are some roles that are running from the beginning to the end, like doing project management. So it doesn't matter the kind of contract, because if we are going in a turnkey, at the end, there will be a lot of project management done by the main contractor. If we are going in a multi-contract, this project management will be done by the owner or by the company supporting the owner for doing this. and it will happen from the beginning to the end. Quality assurance, that has to be happening again all along the project. So we need the project to be compliant with requirements, with quality, especially with safety requirements. So we are also somehow mixing this quality assurance with the safety assurance as well, and the licensing. Then there are different roles. For example, we can do the conceptual design maybe with one contractor or directly by the owner at the beginning. Then we are entering in the construction phase, where we can have a project management consulting company. Then we will see the different types as well. So for the engineering, for the procurement, for the construction, this can be management or only construction management. And we can have the main contractor. So EPC means engineering, procurement, and construction. For sure, it's not here in this graphic, but then we will have operation and maintenance, and then we have the commissioning and dismantling at the end of the project life cycle. More things. In the very earliest of the project, for example, there are some challenges. And because at the very beginning, we can have a lot of influence. So when we are doing the conceptual design, for example, as we say, the government, the international authorities, they can have a lot of major influence in the project. This graphic we want to represent that at the very beginning, we have a lot of influence. This is the curve of the influence. At the end of the project, we have less. So we are doing the first phases of the conceptual design for sure. And we can decide, it's where we are deciding everything on the project. So the influence is very big. Or imagine we need to financial the project. So if we don't get the financial, so the influence is so much that we are not going to do the project. Or they put some constraint for this financing of the project, so they have a lot of influence. So as long as we are developing more and more the design, this influence start to decrease because we are starting to fix things. For example, we have our layout that is already fixed, things that then we cannot move. And we are defining more and more the project, so the influence start to decrease. There will be a moment that we will start to build, so we have very, very limited influence in the project. But then the cost go in the opposite way. So at the beginning, we don't need a lot of resources to have a lot of influence because we will have, as we can see in this graphic, very limited manpower. Some people doing the design, one person responsible of the owner. But then as long as we are doing the design and we start the construction, the manpower increase. And here, as we can see, with a very limited resources, we can have a lot of influence. And then in the opposite, there is a moment that we have a lot of resources with limited influence. So what does it mean? That it's very important that at the beginning of the project, that we have in mind everything that we want to do, the strategy, the main decision, technical decision, everything has to be thought at the beginning. Going now for the type of project management services, what we can do as a project management consultancy. Well, this graphic just want to represent that we can have, at top of this, we have the owner, we can have a project management consultancy, we can have an EPC contractor, it's the equivalent to the turnkey, so it's a contractor that is doing the engineering, the procurement, and the construction, so the whole responsibility. So, and then this contractor need to have some management to manage all the subcontractors, the engineering, all the suppliers, all the construction, or all the different contractors that they can have, because then they are going to do the same as we are doing multi-contract, so they have to contact all the discipline and all the works to be done. So they are doing a lot of management by themselves. But requirements for project management consultancy. So for sure, experience in nuclear requirements. It has to be a multidisciplinary and very well integrated team with an integrated approach. Experienced people and qualified, so especially in the nuclear sector. We need to customize all the methodology, all the processes, all this strategy that we have said, that we have seen, has to be customized project by project. We need also as a consultancy to take care of the compliance of the requirements of the client, the scope, the requirement, the schedule, the budget. We have to have knowledge as well in the international support by the IAA or the NIA. We need to have on-house international experts and advisors to make decisions, to supervise design, for example, and a very deep safety culture. So these are the main requirements for the management. Then we are going to see now all the functions that can be done as a project management. Before entering in the function, it's important to know the different type of contract that we can have as well doing management. The first one, as we say, is the EPC contractor. So it's the equivalent to the turnkey, as we said. So because they have the responsibility of doing everything, doing engineering, doing procurement, doing construction, and also the commissioning. So in this case, the management, all the management tasks are under the main contractor. They have to do the management by themselves. We can have also a contract which is called EPCM, which is Engineering, Procurement and Construction Management. That more and more, a lot of owners are choosing this approach, where the engineering is done by this contractor, the EPCM, but then for the procurement, construction, and commissioning, they are only doing management. So they do the engineering, they support the client in all the call for tenders phases, choosing all the rest of the contractor, and then they manage them doing the construction and doing the commissioning. Or we can have a poor project management consultancy contract that they do the management, only management of all the phases from the design, even from the very early stages of design, conceptual design, until the commissioning. Or we can have just only management for the construction phase, for example. So depending this type of contract, it's not the same investment in the project. For example, if we are going to an EPC contractor, so it's 95% of the investment of the contract because we are giving everything to be done by them. So most of the budget will be dedicated to this. If we are going for a PCM contractor, for example, it's only normally 6-10% of the whole project investment. We are going now to see the principle. We're not going to stop a lot in all these tasks because now we are going to see in details. Because we have to manage scope, planning, cost. Some people call this like scope, time, and cost, like the triangle of the project, but also considering quality and safety, especially in nuclear inside. But also we need to manage risks, human resources. It's something that we cannot forget because at the end the projects are made by people. So we need to manage the people, we need to take care of the stakeholder, we need to make them to be committed to the project, to be the good specialist, to do a talent retention, because some people maybe if they are not comfortable what they are doing or they don't feel that they are professionally growing, maybe they are going to go to look further at other projects, other companies. So this is also important to manage. Quality assurance, for example, we have to do the quality assurance. Another point that is very, very, very important are the lesson learned. So lesson learned is not only that at the end of your project you make the list of what happens and only you say, okay, all the negative point that has happened is also the positive, and it has to be done during the whole life of the project from the beginning. So they will help to put all these lessons learned for the next project to improve them, not to have the same mistake or the things that has worked well to repeat it and to incorporate it in your way of management. Then we have to deal as well with the legal and contractual, because at the end, this is a project. We have a lot of contractors. We have a lot of contract put in place, so we need to manage this contract. we can have claims. We need to manage the claims. So at the end, claims sometimes are seen like a better negative in a contract. So, but in a lot of international contracts, so claims is a tool that you have in your contract as well to manage the contract. So we have health and safety, the communication, coming back to stakeholders. So we have a lot of stakeholders. We have some of them can have more or less influence. We need also to manage this communication. We have to fix at the beginning of the project how many meetings we want to have, with whom, between whom, who are going to be the single point of contact of each one of the companies. For example, if we have a 10K contract, we will have only one voice, only one single point of contact to discuss. If we're in a multi-split contract, we will have maybe, I don't know, 20, 25 people to discuss. So maybe we will need also meetings to discuss between them to solve coordination and interfaces. So we need also to manage this. And there is another point, which is the configuration management, that I think that is something that is as well not always very well estimated. For example, here in ITER, is a very important topic and very difficult to manage. So what we can think that is configuration management. So we can think, for example, is the control of the documentation. Documents with the naming, with the version, if they have been signed and approved by all parties, it has been approved by the owner or not. Also physical configuration. So we can work in a 3D model to see clashes, to see if things are fitting or not. Also in the timing. So sometimes we cannot do one part before we start doing the other. We need to leave some temporary opening because if not, we cannot put all the components inside the building. So this configuration is very complex. Here, for example, in ITER is something that is consuming a lot of resources because as we have here like a multi-contract scope, we will see later on. I will explain more about this project, but just to let you know my experience. So sometimes the contracts are put in place in different times of the moment. So when we put in place the civil work contractor, we have some requirements coming from ITER, like it's the equivalent to the utility, the owner, the nuclear operator. So we have the requirements in one moment, but maybe then we put in place another contract for the electrical system 2 years after. So maybe the requirement has also evolved. So we need to have this traceability of the requirement that we have in one contract, in the other. Then we need to see the impact of having different requirements, the adaptation, retrofitting sometimes. An important thing to manage that sometimes is not very well thought. And it's very, very time consuming. How we can do all this function in management? So we can start the project and just say, okay, let's start. Go ahead. How we are going to manage the schedule? I don't know. Can you have a look to the schedule? So no, we need to have a plan at the beginning. So we need to have a management plan. We need to have procedures for everything. So we need to thought that ways in advance how we're going to manage everything. The planning, the risks, the contract, how we're going to put the contracts, the rules to put the contract in place. So we have to have procedures, methodologies, templates. So everything has to be thought at the beginning, because also this will help the project manager, or even it will help as well the owner. It will help to manage, it will help to make decisions, it will help to have some guides. We need to think about the risk as well. It has to be thought at the beginning. So then the owner can have also their own procedures, the project management as well, to be developed and really detailed and tailored for the project. And then the contractor has to have their own procedure. Everything has to be linked for sure, because we need to consider the requirement from the owner to develop the management, and then the contractor has to comply with all of them. Then also we need to have an organization for all these people working in the management. So we need an organization because we need to define responsibilities, who is going to do what, not everybody is able to do everything. For example, someone specialist in cost is not able to do design or to manage design. So it's important that we have a clear organization. For this is the typical one with a project manager. We have the configuration and requirement managers, quality, nuclear safety, control of cost, planning and risk. Then we have the engineering with the different disciplines for all the things that we have to do. Then if we are doing a part of the management or of the engineering, the construction and the procurement, is a very similar organization than this part, but dedicated for procurement and construction. What is happening normally? So part of this team that was involved in the engineering management is the same team that is involved in the construction or in the procurement management. So they are taking advantage of the background and the knowledge of the project for doing the design first, to support in the procurement and to do the follow-up of the construction. Is what is normally happen. And now we are going to start to go one by one of these functions to see more in detail what are the functions that can be done in each of these phases. So in the management of time and cost, so we need a schedule. We need to manage the schedule. We need to know which are the main milestones that we have to comply, because maybe this is a constraint. Maybe the main constraint of the project is the milestone. We need to finish a plant in a moment of time. There could be political reason behind, or just economical reason. We need to put the plant ongoing and working because we need to start to have contracts and to start to recover the money. So these are these milestones. We need to have them in mind for coordination activities. So especially we have a lot of contractors, we need to coordinate activity between them. So we need to have a planning coming from the party and integrate it to be able to make the decision and to give priorities to one contractor to the other, one discipline. Also, it helps to control the expenses, to have your cash flow prepared. If you are in the part of the owner, you need to think about your cash flow. How much money are you going to spend each year? And you need to assure, because maybe sometimes we have public financing, we need to comply with the money that we need to spend each year. So this is also important. So the schedule, we can have different levels of the schedule, an overall one. For example, in ITER, we know the first plasma has to happen in 2025, and the deuterium system has to be happening in 2033. So these are big milestones that everybody knows and has to be complied. Then among these, where we can define engineering. So the engineering has to be finished in that date, then the licensing, all the procurement, then the construction, and then the commissioning. Then we can go to another level 3 with more details, that we are detailing all the tasks and all the works to be done in each one of these main tasks in the master schedule. Normally the owner, the utility, is focusing this part, which are what they are more focused, especially maybe in level 2. Level 3 is more if we start to have some multi-contract that we need to coordinate all the tasks. And then the contractor are going more in detail in the planning with very detailed tasks for the manufacturing, for the supply of materials, manufacturing, construction. So they have a level 4 with very, very, very detailed. So we need to control from the beginning and until the end of the contract. Also, the schedule will allow us to make decision of changes or deviation of the project. For example, if in a moment of the project a new requirement is coming or a change has to be implemented, we need to check the schedule. We need to see if it's possible or not, or the impact that it can have in the schedule, then to make a decision. And cost, as we said before, scope, time, and cost has to be controlled. So we need to know the budget. What happens at the beginning? At the beginning, when we are in the preliminary design, we don't have so many details, so we have to do a rough estimation of the contract. How do we do it? We use other similar contracts. We make an estimation. Maybe we know in other countries. We take some contingencies, for example. Sorry? Oh, no, I thought that maybe someone have a question. As long as we are developing the design, we are having more and more details. when we are in the detailed design, we are able here, for example, to do a complete bill of quantities and bill of materials, and to put prices and to have a really good estimation of the budget. Then when we put the contract in place, maybe we are going to have real prices of everything. So at the end, we will know the total cost. Regarding the cost, we have to manage as well the payment certificates. When we have the contractors, we have to pay them in a monthly basis, or depending the type of contract, or quarterly basis. So this cost has to be also controlled. If there are changes or deviation, maybe deviation as well has an impact in cost. So we need to evaluate them, we need to control, we need to see if they are able to be implemented or not. As I said before, the cash flow as well has to be managed. Also, maybe we can see that we are starting to deviate from the budget, and we need to start to do corrective actions. Maybe we need to come back to some of the decisions that we made to decrease the budget. And there is a very interesting tool that is contrary at the same time cost and time, which is called earned value management. It's really used in all the projects, especially in the big ones. So what we want to control? We want to control, we see here in the graph, the black line is the planned value. So we have the budget of the contract, we have the schedule, we know what we have to spend each month. So this is our planned value, which is the cost. But then we have the reality, what we call the earned value, the line in peak. So it's really what we have done. Okay, and then we have also the actual cost. It's really what we have spent. So how much money we have spent. So we need to see these values. That helps a lot to see where we are and to forecast what could happen, and to take some remedial action if we see that we are deviating a lot. For example, in this case, in the peak, the earned value, we can see that it's in pink. So if our planned value is this one in black, what do you think if you see that our earned value, which is what we really have done, is below? So we are behind the schedule. We are not achieving our target. It could happen the opposite. Maybe the earned value is above, so is that we are faster than we have planned. So this will help to see where we are. And also if we see this, if we forecast this in the future, maybe we see that to achieve the end of the project, we are going to take a lot of more time. So in that moment, maybe we need to make a decision, some corrective action to be back on time. For example, doing double shift in one of the contractor, or start to do some works in parallel. It will complicate the co-activity, but maybe we need to do some action and not to wait until the end of the project to really see that we have not achieved the target. How we manage this normally with monthly or quarterly reports. And it's important, this is an example. We cannot see the detail, but it doesn't matter, because what we want to show here is that it's very important that this, all these values of the progress of the works or of the status of the project can be seen in only one page, because maybe this report will go to top management people. They are not going to spend 2 days reading a report. They want to see in only one cover page the status of the project. So we see we are here, it's in that it's okay. We see we are here, maybe we are, it's in green, we are better than we thought. So with only some graphs and the main problem that we can have here and risk, in only half an hour, someone can see where we are in the project. The risk management. So I think everybody, when we talk about risk, we also think that risk are bad things. But it's very important in the project management to think about risk, that another tool to manage the project. And really important, because what we have to think at the beginning of the project, which are our risks. We need to have them in mind. We have to have a plan to solve them in the moment that they appears. Or we have to put in place mitigation action from the beginning to avoid that the risk happen, or if they happens, that they will be as limited as possible. And we need to manage the risk along the project. So they have to be reevaluated. Time passes, things happen, and maybe some risks disappear, others new appears. So, and then we only say risk management, but in reality, we need to think about risk and opportunity management, because we can have risks that could be negative, but we can have also positive things that could happen, opportunities to put in place. So also they have to be thought as well as the risk. How we evaluate the risk? Maybe I'm going to make it with an example. So for example, the risk, we need to evaluate the risk with quantity and probability, because it's not the same. An example, for example, we have a hole in the floor and we are working in the street. So this hole is a risk because we can fall in, but we need to think, is the hole big or small? Is deep or is very shallow? So if the hole is very small and very shallow, there is no risk, nothing to do. You are going to, just with doing a step, you are going to solve it, no problem. So maybe we don't have to take much care about this risk. It can be also that the hole is very small but very deep. We don't care neither, because only with our foot put on the hole, we will not fall. But then what happens if the hole is very big and very deep? So then we have a problem. This is a risk. So what we have to do, what we need to do, we need to put some mitigation action, because if at the end we have to cross in that part of the street, or we put a fence, or we cover it, or we fill it. So these are the mitigation action that we need to put in place to avoid that this risk happen. So that's why the risk has to be evaluated all the time. Maybe when the time is passing because of the I don't know, sand in this road or whatever, and all the dust, the hole start to be covered. Now it's not so deep, so maybe now after 3 years it's not a risk. So maybe we can remove it from our risk register. This risk also will allow us to make decisions, to put priorities, to solve problems, and to go ahead. Nowadays also we are using the building information modeling management, okay, which is doing a 3D model. We know about the specification in 1D, the 2D drawings, the 3D that is common in all the project, but we need to have a model that allows us to go further in the analysis, especially in the big and complex project with a lot of people. So we need to consider the schedule, what we call 4D. Why? Because maybe we need to think in the schedule, because if we close one wall, we will be not able to put big machines in that room. So we need to think in the schedule. Maybe the machine has to be put before we close the wall, or we have to leave a temporary opening. Then it's very important as well the 5D, which is the cost. In the models, but it's very easy to get all the bill of quantity, because if we put all the information when we do a wall of the reinforcement of the concrete, so if we do a modification and we cut here the wall, we just click a button and we have the bill of quantity, so we are going to know the new cost of this wall. And then even going further in this analysis, we have the 6D. So we have to include the management. So as we have the specification, we have the 3D model. So for example, we have a valve somewhere, and we know that we have this valve with this characteristic that we need to be maintained and to do some maintenance every 6 months. So the information we will know. We know where is the valve. We know that we have to do the maintenance. We know maybe the cost of doing this maintenance. So in the whole system, we have all the information. More things to be done. We say contract management. So we have seen at the beginning, maybe we are going in a multi-contract type of contract, or maybe we are an EPC contractor and we have to contract all the other works to be done. So we have to take care of the contract to put in place. Also, we have to take care of our own contract. So also we need to know about this. We have to be able to do contract assessments. Sometimes we are negotiating and some contractor can would like to include a new clause in the contract. So we need to do this kind of assessment to see advantages of disadvantages, if they are in consortium or not, what could happen, all the specification obligations. Important things to consider in a contract. So payment milestone, how we are going to pay or how we are going to be paid. the schedule, the main milestone that we need to know, because maybe some of them could have some penalties associated. If we have bonds and warranties from the bank to be delivered to the client, this also has a cost, has to be considered. A price revision. If we have a very long contract, several years, 3, 4, 5 years, we need to know if we are going to have a mechanism to revise the price each year or not, because we need to consider as well different clauses that can be, or terms for cancellation of the contract. So if we have intellectual property or not. So we need to manage the contract, we need to see this, and we need also to help, we are doing a role of project management consultancy to help the contractor not only to put in place the contract, but also to manage then the contract. Then we can have claims, we have to go back to the contract to see what has happened, what the contracts allow us, what can be granted or not. And if we have changes, how we can put them in place. So link with this, what we say, to put the contract in place, we have the procurement management. We need to think here that we need to normally to comply with requirements, schedule, budget. So when we are doing the call for tender phases or the bid phase to put in place the contract, we have to have all this technical and economical information. We have to have them in mind because we have to comply. As we said before, maybe we need, our main constraint is the cost. We need to go to a multi-contract to try to choose one of the specialists with the best price in each case, or if it's the schedule, just to see who is going to do faster the work. And the support to be done here, yes, attending meeting, doing a specification, technical specification, preparing a schedule, having discussion, doing the evaluation, technical or economical or in the schedule, to choose the best bidder. It's very important that the rules that the owner could have. For example, if it's a public entity, maybe there are some public rules that has to be considered, or the internal rules to do the tender, the timing, restriction, requirements, maybe for the companies to be able to bid. More things, the quality management. Maybe everybody associate very, very quickly the quality as a lot of paperwork and blocking things that are not allowing us to progress, but it's completely the opposite. So quality is helping to manage the project. So quality is helping to assure that we are complying with requirements, with a schedule, with a scope. So it's guiding the project manager. So we cannot think that, okay, I have to do all this quality work and it's going to take me a long time and it's not helping me at all. So at the end, it's exactly the opposite. It's taking care that everything is doing properly and in quality. And more in the nuclear safety environment, that we have to have all the quality compliance record, which is the as a compliance matrix, where we have the traceability of the requirements. So we have a safety requirement, and we have to demonstrate that we are complying with this. So this is also quality. We have to have quality plans as well for the contractor and subcontractor, as we've seen before. All the procedure and management has also to be put in place by the contractor and subcontractor. We have to manage all this supply chain, and we have to be sure that they are complying with the main requirements. When we are doing some manufacturing as well, the quality assurance of this has to be assured. And more if there are safety qualified components, we need to be sure. The process has to be warranty and well traced, so that we can demonstrate at the end that what we are putting in the plan is what we are expecting, and that we comply with all the safety requirements. No conformities. Again, another concept that all the contractors normally are very reluctant to use. Non-conformities. So if we are doing something and we are deviating from the requirements, so in the nuclear sector, we need to track everything. So, okay, it's not a problem. So we have done something wrong, not compliant with a requirement. Maybe it's a mistake. Maybe just we forget to put a rebar in a slab. Okay, but we need to say, hey, this have a no conformity. I made a mistake. One river is missing. Sometimes the no conformities are very easy to solve. Okay, just we put the additional river and that's all. Or sometimes it's not so easy. We cannot put it because someone has realized after the concrete is poor. So, okay, we cannot now put the river. Okay, what will be the remedial action? Okay, let's do a checking of the slab, a calculation without this river. And maybe if the slab is still under the safety coefficient, we don't have to do anything at all, but just we have the traceability that a bar was missing, but we have no problem. So it's also a tool to manage the contract. Okay. More things, as I said before, the stakeholder management. We need to know among all the people involved in the project who has more influence and more participation. Because imagine that we have, I don't know, the government. It can have a lot of influence, but maybe only at the beginning of the project. So at the beginning, we have to pay a lot of attention of the government and the laws and what we can do or not. But once this is solved, maybe they are not going to be more involved in the project. So we need to see if we have a stakeholder with a lot of influence and a lot of participation, we have to take that into consideration in our stakeholder management. Maybe we have to have weekly meetings or monthly meetings with them. We need to identify who will be the single point of contact, who is the decision maker. So this is important to have also identified. Then we can have, I don't know, a third party that is not so influenced or is not so participating or have. So we need to manage this. We need also to manage expectations. So for example, imagine that we are in the level that we have the owner, we have a EPC contract, and we are one of the subcontractors of the EPC. For us, in this case, that we are in this level, our client, direct client is the EPC, but we have that on top of this, we have the owner. So we need to know who are our people that we need to talk. We need to know the influence. So for sure, the owner, the nuclear operator, has a lot of influence, because if we are doing a design for the EPC and then it has to be approved by the owner, for us has a lot of influence, even we don't have this direct contractual relation with them. So we have to have also internal meetings with the team, with the contractor. If we have a multi-contract, maybe we need to do integration and interfaces meeting to solve all the clashes. Construction management as well. We have to follow up construction on site, do coordination, do integration, control the schedule, control the payment. I think control also in the fact, for example, we have to go some factory to do the factory acceptance test and to supervise. Maybe if we are sharing scaffolding and holding, has to also to be controlled. We have to have also indicators, as well as the safety and licensing. We have to manage through all the project from the beginning, to have all the traceability of the requirements, to demonstrate that we are compliant with them. Depending the role that we can have, we can be the one that we are having interaction with the safety authority of the country or not, or maybe it's directly the owner. For example, here in Italy, it's directly ITER who is doing this relationship with the safety authority in France. And then just to finalize, so I think we have go through all the function that, or main function that can be done in project management. We have to have something that are hidden. I mean, it's like an iceberg, no? We can see this part, and maybe it's the thing that we have seen, but then we have a lot of issues that can happen that is not so evident to see. Like where we are selecting local suppliers. Maybe we are doing the plant in an area where normally there was not before a nuclear project, so the supplier maybe are not qualified, or we have not enough, and we need to go further to look for the rest of the suppliers. So maybe we need to think about the storage area for when we have bulk material. So maybe we don't have a space in our site to do this. worker turnover. Sometimes we need a lot of people qualified that they're not easy to see, that maybe they are going to another project, so we need to manage this, as well as the big construction equipment. So maybe they are not so easy, they are not so near to the site that we are. The public engagement, see management. Here, for example, in ITER, as this is an experimental fusion reactor, so people doesn't know very well. So they associate that this is a standard nuclear facility. So what ITER is doing, a lot of sensibilization sessions, open days, letting people go here, explain the project, the benefits, what is different from the standard fission nuclear plants. So there is a lot of information that is shared with the people, especially with the people around the area, also to be managed. We know there is a lot of anti-nuclear people, so they are doing strikes sometimes in the door of the project, and this has to be managed. We need to show people, to make them understand, to have knowledge. Okay, and at the end, something that is always underestimate the closure of the contract. People think that closing a contract is very easy. We finish and we go, and then there is a lot of things to be done. It's a very, very time consuming and sometimes difficult to close contract. And also just to let you know, for example, all these concept of project management, how we are implementing in the project, particularly the one I'm working with, is at ITER. So with IDOM, we have a role here of support to the owner. So we are just doing management supporting the client. Some information, maybe you know about ITER, you have heard about it, but okay, it's an experimental fusion reactor. So what we want to do here is to replicate the energy produced by the sun. We know there are some fusion reactor all over the world, small ones that demonstrate that this can happen, but this is a real scale project, really to demonstrate that with real scale, the energy that we are going to obtain is big enough to compensate the energy that is used to produce the reaction. So it's an example as well of complexity. This is in the, let's say, multi-contract case, multi-type of contract, a very important number of stakeholders. So only just to know which are the members of ITER. So we have 7 members, Europe, China, India, Japan, Korea, United States, and Russia. So only with this, we have 7 members. Then each one are doing the project is divided really in pieces. So the work breakdown structure of it is crazy. And each one of these members is doing one of these pieces. And sometimes, for example, for part of the reactor, each member is doing a sector. So imagine the stakeholder, the interfaces, the management. So it's a very big project with more than 6,000 people working, doing design, sometimes really research and development design. As I said before, we don't know a lot of the requirement from the beginning, things that we don't know how much they will cost, which will be the implication, all the supply chain, a lot of subcontractors, licensing management as well. It's a problem because, well, it's not a problem, but it's something that is not a standard fusion nuclear plant that, for example, here in France is very clear, all the steps that they have to follow. For example, there are no particular regulation for fusion plants. So in France, they are managing as if we're a fission plant. So we have to comply with the same requirements. It's not exactly the same. And coordination of all these stakeholders. So what we are doing here, so our client is the European Domestic Agency. We are working inside this European Domestic Agency only in buildings, infrastructure, and power supply. We have this scope more limited, let's say. It's more like the more standard things that can be done in a project. Even we have we work in the nuclear building as well, in the tokamak complex, where is the reactor. Our specific task that we are doing here, yes, you can see that what we have said in the theory really are put in place in the reality. So we do tasks related to design. We review design done by the architect engineer or by the contractor, and we manage the design review. So we have design review gates that where the design has to be approved by all the parties, not only by the European domestic agency, also by ITER and by the other domestic agencies. So if we are doing a building that will have inside the allocation of components provided by Russia, Russia is also participating in this approval of this design. So we have this stakeholder management again. We do a lot of contract management, participating in the call for tender, in the bidders, preparing bid specification, doing the evaluation, then managing the contract along the contract, managing changes. There are a lot. So again, the requirements are not fixed, things are evolving, systems are also being designed. So we have a lot of change then to implement in the part of the building. So we are managing as well all these changes. We are reviewing the payment certificates for the monthly payment of the contractor. And we are supporting as well, as we said before, in the claims, because here the contracts are based in fitted contracts. So the claim is another tool of the contract. And then with the construction, we do the supervision, we do management of non-conformities, some progress follow-up indicators as well. So as you can see, so I mean, everything or part of the task that we have done here, we are doing in our role of support to the owner. And how do we do it? As we said, we need a management plan. So this is the procedure map of all the procedures that we have as support to the owner, compliant with our European domestic agency, which is called Fusion for Energy requirements. So we have our quality plan and we have the procedures for everything, for contract management, all this procedure, for design control, all this procedure, for construction, for our internal tasks to be done, our organization chart, our naming of configuration control of our document. So all this procedure to be able to allow us to manage the work that we done and our internal work. So they are put in place. They are just made for the project, for this contract. And just to wrap up all the ideas that we have said this morning, what we need to have in mind when we think about project management. We need experienced people that are able to manage complex project. We need comprehensive information. So everything that we said about procedures, processes, templates, to allow to make decisions. So as we say for the risks, so we need the procedure to guide us to make the decision. We need the nuclear expertise, for sure. We are talking about nuclear project, so it's very important that we have the experience. We need to manage with the project with a risk approach, priorities, as we said before. So it's something that really is not a risk. We are not going to take care. We need to focus in the important things that are really or that could jeopardize the project, and with priorities. We need to foster also the supply chain, as we said before. If maybe the suppliers in the area are not qualified by nuclear, maybe we need to support them to be qualified, to help them to be able to support in the project. Management of the stakeholders. So I'm repeating this because it's very important. The lesson learned to put in place, again, to improve the next project. A team that can be tailored, adapted to the project. The organization should be adapted. The team need be to adapt in each one with the roles, the empowerment, and they have to be committed. It's very important. And more in the nuclear project, that people is really committed with the project. So I would say that this could be a summary of the project management and to put in place. So, and that's all. So now you have questions. We come back to any of the slides. So now it's up to you.
Thank you very much. I think it's clear representation of how the complex the project management and not only in decommission but in nuclear related fields in general. So do you have any questions to Anna?
I have a question, if it's possible.
Okay. Yeah, Roman.
Can you hear me, see me?
Yes, yes.
Hello, my name is Roman Voronov. I am from Lithuania and also a master student of Moscow State University. And first of all, I would like to say thanks a lot for such a presentation, because I was working in projects and you managed to include such huge topic, to make a overview of such a huge topic in so short time. Because it's usually regarding the project management, you have either let's say general books, which are too general and you don't know how apply them to the real life, or you have specific books on specific topics and you don't know how to make a puzzle of them. And your overview really provides the integral picture, and what is really important for people working in the projects, because they need to know. Usually working in one area, people do not know what happens in other areas, and it's very important and to know for a good specialist. And my question is very simple regarding the earned value and the dashboard which you was showing.
Yes, I'm coming back. Yep.
Yes, this one. And here we see on this graph we see earned value and plan value, and but we we know that usually there is also actual costs which usually exceeds the
yes
the
exactly. Normally
would it be also included here, or is it
yes
done
no usually it's included. This graph doesn't have it, but normally we put the 3 lines in the same graph. Yes, as you say, normally
okay.
most of the time the actual cost is here, and also
Yes.
because we make the difference between earned value and planned value and the earned value and the actual cost. So yes, normally we can see the 3. Maybe I can put another graph before sharing this presentation to all of you.
Okay, and the question regarding the dashboard, it's really a very good tool for having the whole project on a snapshot of the project on one page. And is it, I don't know, is it done manually, or there is some special software to create such
Well, some people have special software, and some owner, for example, has some information, everything gathered in one system, but it depends because information is coming in part for the schedule, for the scope. So normally you can have a tool integrating everything, but most of the time I think it's more manually, because it's a summary of the topics.
Okay, and you also mentioned that when we are in a green area, the things are going better than expected. So our, let's say, plant status should be somewhere in yellow, and green means better.
Yes, yellow is like the what we plan. So green is better than plan, and red is like the light traffic. So
okay, yes, just to understand this.
The more green it is, the better it will be. If we finish before the schedule and we finish with less cost than expected, for sure, it will be better.
Okay, thank you so much.
Welcome.
Thank you. Any more questions? Yes, so this sound, but can you come closer?
So there are three scenarios. One is time versus cost, which are interdependable. Another scenario is realistic scenario, and third scenario is probabilistic, what you proposed also in the lesson. So these 3 scenarios are completely discretized independently and has to optimize at the end, or 3 scenarios has to be maintained within the project management.
Could you repeat the beginning, because I didn't understand very well?
Okay, so time and cost, they are interdependable, and when time increases, cost by default increases. So this is one scenario. Second scenario, you have a probabilistic scenario. I have this much amount of cost and I have this much time plan. This is a probabilistic scenario. And the third is realistic scenario. So how these three scenarios has to work together to have an optimal solution? Because ultimately we have to minimum the time, minimum the cost, minimum the with a target. So we are basically optimizing the whole three scenarios.
Yes, so you have to have follow them in mind because the realistic is where you are. The probabilistic will allow you to make decisions. So you cannot then, you need to work always with the three of them. Yes. To allow you to make decisions for the future.
So iteratively, we have to, these three parameters iteratively have to be optimized. With respect to time.
Yes, sure. Always we need to optimize, and we need to, if we are deviating, we need to come back to look for solution to come back. Yes.
Somebody else? No? If it is not the case, thank you, Anna, again.
Yeah, thanks to you. So we will share with you this presentation so you can share with everybody in the master.
So now we'll have just a short break for 5-10 minutes, and we'll continue with the next presentation. Okay. Thank you, Anna.
Thank you. Bye.
Bye.
Important. We are mute now. It's the most important thing. Okay, so once we have summarized a little bit about backend, what is the backend? What are the main differences between the technologies, the processes, fuel cycles, etc. We are going to briefly talk about Spanish situation. Okay, you know the Spain belongs to the European Union, and our energy mix is severely influenced of the nuclear electricity power coming from this source. More than 26% of the electricity came from nuclear. So means that it's very important the nuclear energy source in Spain. It's not, is what was changing in the past. I mean, the last 10, 20 years, let's say, because renewables were entered in the mix sharply, strongly. So we have a lot of wind power, 13%. We don't have so much hydro because there's no electricity, there is no raining sometimes. So we cannot have as a backup sometimes. So we only have as a backup energy or power generation. We have the fossil plants, but basically gas power, because coal is almost zero in Spain because there was abandoned. Was phased out because of the regulation, the European regulation of emissions. Even though in the last weeks, precisely because there were, we have a rise in the electricity prices in Europe, one of the fossil fuel plants restart in Spain because there was not enough power, electricity at that time. If you don't have enough wind power, it is sometimes always depends on the wind characterization and the circumstances of the weather, and also for solar. We know that solar only works in the when sun. So again, we needed to restart this coal plant. So it means that when we would have one or two nuclear generators fully noted, we can have problems. And the prices are sharply going. And we expect for this winter to rise up again. So we could say that the nuclear is the first producing electricity, it's the first source in the energy mix. It's the essential backup source for renewables because the working is, base load. So you have nuclear more than 7,900 hours per year, which is very close to the 8,000, the maximum. As you can see here, we have more than 7,800 hours of production. And again, the coal is in extinguished phase. Natural gas is running because we have a lot of combined cycle power plants in Spain, gas power. But we have a problem that we don't have gas. It's not the same in Russia. And we have a high dependence of others for supply gas, and the production of electricity coming with gas. The most important parameter is the cost of the gas. It's more than 85%, around 70 to 85% of the cost of electricity production coming from the combined gas power generation is just the fuel. And then that's the reason why the prices will go up when you are using the gas as a backup, when you don't have enough renewables. So this is, it's a typical discussion now. Even now in Spain, there is some debate for this. It's very important because having a debate for nuclear is a lot. But this comes because the prices are rising. Prices are rising. But this is the mix. So we want to, the authorities want to go to renewables, just renewables with gas. That was the decision in the transition stage for Spain. There are some other figures here about the electricity system in Spain. You see that the availability factor is very high for the nuclear. It's 92%, more than 92%. The availability factor is the relationship between the number of hours that the nuclear fleet was connected to the grid and the total number of hours of the considered period. Just consider time period, and you have 92% of availability at that time. In 2020, it was pandemic year. And the load factor is close to 90%. That means the relations between the electric energy produced within the time period and the amount that would have been produced in the same period while operating and rated capacity. So very high too. 91% of unit capacity factor, capability factor. That capability factor is the percent of maximum energy generation that the fleet is capable of supplying to the electrical grid, limited only by factors within the control of the fleet. So, as a summary, we have a strong nuclear short in Spain. So we could have a very good backup, in this case, backup, when renewables are not running. Even though we have, we can see that the grid is mostly suitable to work with renewables. There was a lot of investment in Spain for this. Red Eléctrica, which is the operator, spent alone a lot of money just to try to get the best grid for renewables entering in the mix of electricity. So we have a good, good network, let's say. We are not expecting blackout. Don't expect having blackout, because there are some news in the press that every time talking about this kind of blackouts. It's not expecting that we could have this kind of problems, but we could have problems with the prices. And we will see. Here you have a graph with the percent of each energy source. Nuclear 22, more than 22% of the electricity generated is coming from nuclear. You see the wind, okay, wind is over there. In some cases, it's overtaking the nuclear. So what if we have good wind? No problem. We used to work, used to run. There are capabilities to do so. But it is very interesting to see how the net installed capacity is very low. No, but this is because the nuclear is working very slow. Nuclear is working very slow, and with less net installed capacity, you can produce the same electricity. This is something very important that usually, the people generally need. The people that work at the what people don't aware that it's very important to have the same amount of electricity. You will need much more our net installed in the country. This is more information. So we have 7 reactors in 5 locations. So we have more than 7,000 megawatts, electrical megawatts. So more than 6% of the total. Leader in electricity, more than 55,000 gigawatt hours. And also it's important to know that there are a clear avoidance of emissions, of CO2 emissions. These 20 million tons of CO2 were avoided. And more than 33% of the CO2 avoided coming from nuclear. So probably a good way to solve the the triple problem coming from the electricity, economy, environment could be nuclear plus renewable. Not renewable only. But this is something that should be explained. It's necessary having a debate, serious debate in the countries to know how will be the way to get less CO2, but keeping the same electricity capacity. But this will be another issue. Let's go to the facilities in Spain. And we will start with the plants in operation. So we have 7 plants. The first is Almaraz MVP. We have 2 units. It's a PWR, 3 loops, Westinghouse design. Start operation in 1981, Almaraz 1, and 83, Almaraz 2. Those 2 units has a very good performance in the last years. I mean, even I think we have sometimes. Oh, used to happen. So Almaraz has a very good performance of running, and it is considered one of the best for IMPO and one. And it is a very good nuclear power plant. Trillo, which is the newest one, which is a KW Siemens KW reactor, PWR, 3 loops. This is a big difference in between the convoy coming from KW Siemens, now Framatome, now. This design was 4 loops, was a convoy type. But in Spain, we decided at that time having 3 loops instead of 4 loops. It was because the main of them were 3 loops that you see with ASCO 1, ASCO 2, 3 loops, PWR, Westinghouse. And they thought, and they just 2, so they thought, okay, we want to have 3 loops instead of 4 loops. It was a crazy thing because complicated a lot the design. That was coming from Germany. The design was 4 loop, 4 generators, 4 pumps, for everything, for 4 loops. And when we signed, it was participating in some phases, of 3 MPP. And there were a lot of problems trying to get 3 loops, especially for cooling components. So, but there was a decision because they were previous learning about NRC requirements, and there was a mix of guides coming from Germany and coming from NRC. So it was a very crazy thing. But in the end, they have a very good performance, good reliability factor, and everything is fine. ASCO 1 and 2, this here, so this is also a Westinghouse, a little less power, They start working in 1985, 83, the first one, 85, the second. We also have Cofrentes. Cofrentes is another design. It's a GE design. It's a BWR design, Mark 6. More than 1,000 megawatt, 164. Start working on running 84. And Vandellós 2, which is also a PWR 3 loops in 1987. These are the plants in operation now in Spain. I will go for the next one because the time is running out. Plants in the commission. We have Vandellós. It was the first unit that was dismantling in Spain, but was not definitive, let's say, immediate dismantling. We will see later on the strategies for this. Zorita or José Cabrera, which is the second. That was the first MPP. José Cabrera is this one. It was the first one in operation in Spain. There was, in fact, demonstrated project coming from Westinghouse. After this project, this one loop project, they developed the 3 loop for Westinghouse that we have seen before. And Santa Maria de Garoña, which is the last one. The first power was in 1971, but shut down in 2012 after 41 years of it. Now the 3 of them are in dismantling process, different dismantling stages. Okay, we will see later on. And now the stakeholders. So it's important to know what the stakeholders in to manage the Spanish nuclear package. Do we have electric companies? Iberdrola, Endesa, Naturgy are the main owners. Nuclear power plants owners, operators, ANAF, Marastrillo, and Cofrentes. We have a regulator, Consejo de Seguridad Nuclear, a fuel manufacturer, INUSA, and a waste and spent fuel management and dismantling organization belonging to the government. So, government company, Endesa. But also we have a lobby for nuclear. So we have plenty of organizations to manage the nuclear sector. And what about the facilities? Because when somebody is thinking how to manage the backend with the wide definition, it is necessary to know if the country has enough facilities to do so. If the country will be able to work with the waste, to work with the disposals, to work with the spent fuel, and this is important to know. In the case of Spain, we have some facilities, but before that, we need to clarify that we have an open cycle, so we are not reprocessing the fuel. We have an open cycle. So once the spent fuel is already spent in nuclear power plants, we need to take them to an intermediate storage, and if so, the final disposal. So we have an important facility, which is Cabril. Cabril, this is in the south of Spain, Córdoba province. You see the picture. They have different capabilities, installations for low and intermediate waste and very low level waste. This is in operation from since 1986. So we have many years of working with this facility. And the facility is just for treatment, conditioning, and disposal of radioactive waste for liquid and solid waste. The disposal currently is the situation. Current situation is that we have more than close to 80% of occupation of intermediate, low and intermediate level waste, with a total of 34,000 cubic meters for this type of waste, and more than 19,000 in very low waste. You look at the pictures, you can see the very low level waste here, which is just like storage. Most important thing here is just to avoid the leakage of water. So the design should take care about the way of water. And in the left side, you have the low and intermediate waste disposal area with 2 platforms with 16 and 12 disposal structures. You see in each of these structures, you will have this. Okay. So here you have the barrels, and the barrels inside the containers, no? Cask. This facility belongs to Enresa, because Enresa is the company that has the responsibility of the legacy, not only the treatment and disposal of the waste, but also it is the responsible of the legacy, which is that will be in the end of the process. It's just by law, Enresa is responsible. What is the legal framework for this in Spain? So the Spanish law established that before the decommissioning authorization and the transfer to Enresa, it is necessary that Enresa has a formal approval of the decommissioning plan. So there will be a decommissioning plan issued by Enresa to be approved by the CCN, which is a regulatory body. And also the owner has unloaded the spent fuel of reactor and fuel storage pool. This is the idea, the first idea of how to do it. We will see that there are some exemptions, but the main idea coming from the regulator is that, or at least from Enresa to the regulator, is that the owner has a full default. And also, it is necessary to have condition all the radioactive waste during operation to be conditioned. Okay, so before start to the transferring or the decommissioning phase, the operational waste should be solved. This is not always okay, no? This is the theory. And the Nuclear Safety Council required to the owner a new set of official safety documents. So you know that during the operational license, you have the documents that allow you to operate the plant, and now you will need new documents because you are going to start a new phase. Precisely that, by the way, it's not just you say, okay, I'm going to decommission. This means that doesn't mean that we are not going to operate. Okay, so there will be a different phase of operation, and then there will be new documents to be sent to the regulator. And just for information, what are the functions of the regulatory body? Same usually in any country, nuclear country. That regulates the operation of nuclear and radioactive facilities to ensure that they uphold safety criteria and propose rules and regulations forwards the necessary nuclear safety and radiation protection regulation proposals to the government and adjust domestic legislation to comply with international legislation. So, Consejo Nacional Nuclear Regulatory Body is an organism that reports to the Cortes Generales, so it has a very high level of inside the administration. So they need to report to the Cámara. So they report regularly about what happened. I think it's in other countries. Okay, what is the Spanish nuclear phase-out program? We will talk a little bit about strategy and definitions. Okay, strategies. What is the decommissioning strategy? The decommissioning strategy definition coming from the EEA, is a chemical and administrative actions taken to allow the removal of the regulatory controls from a nuclear facility after it's shut down and the return of its site to an acceptable end state. So this is the definition of the decommissioning strategy. So, yeah, you have a question?
The previous slide.
Yes. I will try to go to the previous one. This one.
So, it means who is the owner here? A private vendor can be a owner in this case?
Can you repeat the question, please? I didn't understand you.
The owner.
The owner.
Who is the owner here?
The owner.
A private company or vendor can be owner here?
No, the companies. Companies are private companies, the owners of the entities. There's no state, let's say, public companies owning owners of entities. Yeah, that's only there are companies,
No,
private companies.
Yes, okay. So if NS
In Russia.
is government
Yeah.
regulated. So is it, for example, a millionaire come out and want to be the owner of the nuclear reactor? A private person, a private company, a private vendor can be owner.
No, yeah, I will explain later on about the transferring of the ownership. Okay, there will be a transfer of ownership coming from the operator to an investor. I will explain later. Any question? Okay, so we go for the next one. I will explain that because it's important. Okay, so what is the strategy? We have immediate dismantling, we have deferred dismantling, and we have entombment. These are the three that are defined by the IEA. The immediate dismantling starts in a few years. It's just start immediately. Once you are decided to definitely shut down on the unit, you will start with the activities of dismantling or the commissioning. The deferred dismantling is that you are going to put the reactor or the radiological part of the plant in the safe stage, safe enclosure. Safe enclosure to be dismantled later on. So it means that you will have in a safe condition, which is considering the definition of the strategy and the main purpose of the decommission, but they will spend more time for this. They will wait for a decay of the radiological material, which is a different strategy. And the entombment is it's a kind of encapsulation. This is the case of Chernobyl, for example, but also the case of Bandejas 1. That was the first unit that was dismantling the safe enclosure, the third dismantling in Spain, because there was a graphite design, French design, and there was an accident in the turbine, and there was a fire. There was no emission to the atmosphere, but there was a decision to definitely shut down the unit. And I will have here. This is the safe enclosure. Okay, this is Bandejas 1, and it was because it was an accident, and they dismantled everything except those parts of the reactor containment, and all of them are inside, so they are in a latency or let's say passive state. This is a safe enclosure strategy. Okay, defer dismantling. And entombment comes, let's say, it would be a different strategy, and it doesn't mean that it's used to happen, okay? Because they're going to spend a long time, very long time, not only for the cave, but also for everything. So this is not the type of strategy that authorities like to do. No, like we will see that there's always some cases that there is no choice. Okay, you have an accident, you have a situation that you need to do things to encapsulate the high activity for a long time, because you don't really know what's inside sometimes. But I take this one. I think I have it from energy. I think it's very interesting to know what the difference in between the different satellites. In Tolman, you see that they will have more than 100 years of process, but they will terminate very soon after this time, just 2 years. So they will not spend a long time. I also have this example from Savannah Riverside in the United States, which is the P reactor, the plutonium reactor. This was just for weapons, okay. But they decided, I was personally at the site, okay, not inside, just around. And there was a decision of entombment in this case, okay. And you see how, you can see here, how was the reactor before the actions, and the action they taken for entombment, okay? And they grew, they made concrete and remain like this. So this is a case of entombment. There's no a new, let's say, containment. In fact, there are only improvements inside the containment. That was previously in the reactor. The safe store, you see here, 60 years, and 7 for decontaminate and 2 for them. So I think it's very interesting to see this, the different strategies you can use. Generally, now the international organization wants to be immediate dismantling. About the cost, there are different reports. It's difficult to know and to discriminate how will be the best for the cost. But most of the organizations worldwide and the countries worldwide are using DECON, which is the immediate dismantling process. I get some guides. You can read them. I don't have time, so I need to go to business case. You have here some guides for you. You can read them. They are very important to know what's the process of commissioning. I recommend you to read them. An important thing is that INRESA select the immediate dismantling for Jose Cabrera, because the first, that the first one was Vandage's one, was a SAF, was a safe store. It was a different technology because they were not, there's graphite, there's no clear, there's no clear treatment of graphite, and they decided the safe store. But after that, they decided at that time to go to immediate dismantling for solid. It was important because it was the first time they decided they do this work. And after that, the remaining reactors, at least from the plants, they are not going to be safe store or total. Okay, they will be immediate dismantling in Spain. Some guides also, I will rename this for you. They are the most important regarding the commissioning of manual waste management from IEA and EEA. I recommend to just to check them. And what is the main data for the phase out program? We have a Ministry of Ecology that phasing out the second year. Okay, the calendar is very tight, starting 2027 with the Amaral 1 unit and ending with 3-year BP in 2035. So meaning that the first one will definitely shut down in 2027 and the last one in 2035. Meaning that in 2035 there will not be nuclear power in Spain if everything is like now. it's already signed, and it's a government agreement, and this was sent to the European Union as a plan. RESA, as I explained before, is responsible for the smuggling and waste management and fuel management in Spain, and takes the site, that answers your question, takes the site transferring from the operator when the spent fuel is on the fueling state. So it means that there will be an agreement. I will take the last or last people. They will take the responsibility of the site once the spent fuel is out of the pool and the fueling stage. And there is an agreement in between the operator and the site. There was a signed contract. They signed a contract where there is conditions to transfer the ownership to Enresa for this money. Okay, and this is something that should be signed by both sides and accepted. I mean, the main articles. I mean, the purpose of this contract is based on something, on a strategy that should be accepted by the regulator. Okay, so the players here, the regulator always, the operator, and Enresa. And once Enresa has the ownership of the site, they will start working with the decommissioning, dismantling, waste storage, waste treatment of the plant. Okay?
Who will take care of the financial part?
Very interesting question. The financing part. Enresa is responsible of do that. Each megawatt hour that is produced by entities, by the operators, there is a part that go to Enresa as a source of financing for the decommissioning and waste. The money is coming from the operators. So there is a tax, a canon coming from the operation. We are paying day by day with a specific rate, okay, to finance the final costs. This is a very interesting question because it used to have less money than expected. That is probably necessary.
What happens if the money ends? Is not enough?
Very good question. This is the most difficult situation. If this happened, somebody should pay. And then somebody should pay.
There is not somebody, right? In this scenario, the government must take care.
In the end,
No choice.
if there is not choice, because in the end, the legacy is, as I explained before, is coming from us. Enresa is responsible for the end of the nuclear power. So if there is no money, there will be a negotiation in between the operators and Enresa. I mean, the utilities and Enresa. But this is a very important matter because it's not easy to know how will really cost each of the commission plan, this money of this plan. There is some numbers that were prepared by Enresa, but these numbers should be, let's say, agreed, yeah, depending on what will be the cost of each one. So 7 units, so it's a lot of money, more than. Estimation coming from Enresa is more than around 5,000 million euros.
Will ultimately, in practice, public has to pay through taxes at the end.
Too much taxes.
Only
You know, the financing of the decommissioning and dismantling of nuclear power plants is an issue that never was thought with enough care. Let's say. You start working, you start running, you build a new plant, but you are not thinking what's going on when the plant will be shut down, definitely shut down. No? Lately, the IEA was asking for the commissioning plan, for a new build plant. Okay? They're asking for it. At least there is something. Before there was not. But another thing is the finance. The financing depends on the country. In the case of Spain, the financing in the end coming from the operators. If there is no money, we will pay.
It's also observed in a very realistic scenario. I'm talking about my country. The planning occurred 10 years before. The operation started design started today. So 10 years after the operation of the power plant, and after 20 years or 30 years, there will be commissioning, for example. So we have a budget from now.
Yeah.
But 20 years after, but the most important thing happened, the cost of every object, labor cost, management cost, technician cost, they
Will
were
rise.
increasing.
Yeah.
That is not predictable from the beginning within the design cost. Second thing, international currency exchange. That also has a very deep impact
Mhm.
on the, because if it is a foreign country installing, for example, Rosatom is establishing our plant in Iran, for example, the currency value has a big impact, which is not seeable beforehand. And
Yes.
those two important factors, the currency, international currency exchange value, which is fluctuating and unpredictable, and second thing, every country, it is very general. If you take a regression analysis, you can see the cost of value increases. These two parameters
Mhm.
is the biggest hurdle for any procurement of any designer or any vendor to predict beforehand.
No, of course, I agree. I agree
And
that
how to fix it at the end.
any forecast for more than 10 years is crazy. Always. But we need to manage this. We need to manage this. And yes, of course, it's difficult, much more when you start with a new building, But anyway, wait and see. Wait and see. Let me go straight because I have just 10 minutes. I want to show you, I have more than 20, I think. So, yeah, I will go quickly now. Right now, I will not stop with this. But I wanted to tell you a little bit quick about the Resa Cap plan, because they have a plan. And the plan is that the strategy for the next years is that currently they want to manage the spent fuel in a centralized temporary storage, which is this picture. This is the type of the site previously designed and was not never built. This is a project. This is a future centralized storage facility. But in the plan that they have, because the general aviation waste plan that is now on revision, there will be milestones and calendar of the definitive shutdown of the reactors, the waste and spent fuel inventory, statements and forecast of the waste streams to be generated, chemical solution for waste, treatment, storage, logistic and disposal, a strategy for the spent fuel storage and high-level waste. This is important because they, at least up to now, it's draft, but they keeping the centralized temporary storage remain in the plan with a big, huge investment. I think it was more than 1,000 million euros, but it was never built because it was stopped. There was now suspended the project because there was not agreement. But it is important to say that there will be an ISFI per site. So there will be a 100% capacity of storage of spent fuel in each site. Okay, so this means that strategy is changed. Okay? We are going to having temporary centralized storage, and now we are moving to having ISFIs per each plant. Okay, I think this was already talked it, and the ISFI in the plants that I told you before. Those facilities you can see here for each of the plants, they will be extended for 100% of capacity. So they have ISFIs for operation of the plant. But when we are going to phase out or shut down of the units, we need to increase the capacity of the ISFIs to 100% of capacity. This is under project. So the extension of 100% capacity is under project. So meaning that the strategy was changing a little bit from having a centralized temporary storage and having previously IS files for operation. Once you have the cash and store this plant for operation, you can move them to the centralized temporary storage and store for more than 100 years. This change is changing to the idea to having 100% of IS files storage of the spent fuel in the site. Once it is finished, they will go directly to the deep geological repository. This is the change that we are looking at for our phase, final phase of this nuclear sector. This is about Vandellós. I think I will not take a long time for Vandellós. It's interesting because there was a lot of things to talk to, but I have no time. You can read it. We have the presentation. But I wanted to go directly to Zorita because I think it's a business case and you need to see it. Zorita was the first nuclear power plant in operation in Spain, but also the first one that was by immediate dismantling strategy with greenfield result. You see in the left, this is the plant in operation, and in the right, this is how will be the plant probably in the next maybe 2 years, no more. So there will be a greenfield. Only you will have the grid here because it's from the Red Eléctrica, so it's not belonging to the operator. It's just for the network. Okay, this is the only will remain in the site. And what was how was the way to take decisions for José Cabrera? So you see that you have different strategies you see before, and you need to study a little bit the strategy. What would be the best? And you see the factors, and you see there the results. Waste characteristics and volume. Okay, could be deferred, could be a little bit better because this could be managed, easily managed. For waste management and disposal, really immediate is better. The safety defer because for accident analysis, you see after accident analysis, if you have defer, you will not be in operation during the dismantling stages. So you will have it in safe store, and you go. You just need some let's say, passive operation of the plant. The technological viability could be both. Environmental considerations seems that it would be better for immediate dismantling. Plant documentation and personal knowledge is very important because otherwise there will not be anybody. If you wait 50 years, there will not be nobody that knows the installation. This is very important. Human resources, people who knows the knowledge. Regulatory considerations. Yeah, I told you before that immediate dismantling is the way that, like the regulatory bodies and international organizations in safety. The social aspect, also very important. If you go from there, nobody will work in the plant. But if you say this immediate dismantling, you want not 100% of the people, but maybe because there will be a reduction of people working on the plant, but there will become another people, another organizations, another companies for dismantling. So there will be, let's say, less social way to do it. The site reuse immediate is better because, in fact, in Zorita there is a decision that there will be a solar plant. It was small from the beginning, it's already licensed. I think 1 megawatt, but it could be easily used in the site. Okay. And from the financial and economical consideration, there is not a clear statement about how this has less cost per year. Okay, the main data. Construction of the power station in 1964. As I explained before, it was the first pilot project for Westinghouse. There was many engineers coming from Westinghouse to Spain for this project. So they were very interested in this project. And was commissioned in 1968 and inaugurated in 68. At the 2006 was the government decision. This order, which is the same. The reactor, 160 megawatts electric PWR, 37 years of operation after 37, with very good performance, in fact, no accidents. So, important. Main breakdown activities. We could see what is the situation now, 2000 to date. This is the dates where dismantling activities were performed. 2006 was stopped, was definitely shut down, and after 4 years, there was the transfer from the nuclear operator, that was at that time Fenosa, it was a company in the past, to Enresa in 2010. Okay, Enresa takes the responsibility of everything after that. It doesn't mean that the people coming from the operator are not involved in the project. The people coming from the operator will be in charge of some of the activities in this agreement. There will be operators working during the phase of transfer and transition phase. So preparatory activities finished, system discharge finished, system modification finished, auxiliary facilities finished, conventional dismantling finished, radiological dismantling finished, large components finished, but still some activities in decontamination and evolution that are almost finished, material management, and site resource. These are the three activities that remain in the project. You see here the plant in operation, it was in operation. This is the transfer of a nuclear spent fuel Holtec type. This is the crawler. The crawler is the vehicle that moves the gas from this IS5 or from the nuclear power plant to the IS5. This is the movement. Okay, how move the spent fuel inside the canister. And this is the reactor pressure vessel and the spent the fuel, the pool of the reactor. What about the buildings? Buildings and facilities. There is a plan for buildings and new facilities or refurbish of other facilities. We have 301,000, we have 141,000 tons of material to manage. Okay. Of those, 26% were conventional waste, 10% nuclear waste. And of those, waste potential to be released 64%. So, I mean, that most of the material will be managed as the medium level or low level waste, and only 3% was high level waste. And then that's why it's very important having a program, okay, to manage different wastes that are coming from the dismantling process. And this is you can see here that El Cabril will take most of those wastes, intermediate and low, basically low level waste, but there will be some intermediate level waste that will be managed by El Cabril, were managed by El Cabril. And those ones that are high activity, coming from the internals of the reactor, were stored in casks, in canisters, like I showed you before, and then stored in the IS5. And this is the arrangement or plan of arrangement of the different buildings. I wanted to tell you that the plan for demolition is later on, but you need to make these plans with enough time, and you need to see what will be the storage you are going to have with the dismantling process. You will have some materials that you need to manage them, and you need to know where to store them, where to segment it, where to decontaminate it. In the case of Zorita, there were 3 storages, 3 waste storage. After there will be the wood, they built another one for low level waste. So it's very important to try to get the most, as much as possible information coming from the waste, and where will be treat and store. These are the main plants that we have in Zorita. There was the preparatory activities, conventional element dismantling, radioactive element dismantling, decontamination and demolition, site restoration, and closure. Closure, declaration of closure that will be finally accepted by regulatory body, hopefully, when finished. In all of this process, you will have something very important, which is the radiological characterization. You will have any time in the process. You need to know what it is very important, relevant, behind the characterization, radiological characterization, radiochemical. Yeah, in this faculty. What about the preparatory activities? We have in the transition stage, we have operational waste, conditioning, spent fuel management, polar train adjustments. It is necessary sometimes to change the characteristics of the polar train. In fact, it's a little worth that. Spent fuel transfer to IS5, radiological characterization, primary and auxiliary system decontamination, licensing documents, reactor internals, and vessel segmentation was one of the most important or critical part of the decommissioning. And as I explained before, the internals of the reactor, whether more activated, are stored in 4 casks and disposed at IS5. So currently in Zorita, there are 4 casks coming from the reactor's internal and 12 coming from the spent. Also, there is a deactivation plan, system isolation, draining, boundary valves, so other activities that you need to do before the real dismantling phase. Some other preparatory activities I'm very interested to know is that there will be many system modification plans. Here it's important to see about the ventilation system that will be also changed for sure, and was changed in fact with a lot of work on this. Also firefighting, demineralization water, rat waste treatment. So there are a lot of changes in the plan for this process. And in fact, one of the interesting things in Zorita is that the turbine building was used for as auxiliary decontamination and dismantling facility. So there was a new design, you can see here. Once they take the equipment away, they redesign the building to produce containers, concrete containers to be directly sent to a company. Okay, it was an interesting change. So there is a radioactive dismantling plan for all the equipment, especially for the large components. It's very important. There will be a higher doses. So you see here the process for cutting is underwater. This is another thing regarding the critical works. Internal reactors, how the cask with the spent fuel is moving from the containment to the IS5. The container, I mean, this cask used to be in vertical position when it's loaded, the canister, then it's transferred to a transfer gas, which is this one, we put it on horizontal position and move it to the ice pipe. This is the plan for the contamination and demolition plan. You need to have a clear block plan and necessary stages we are going to follow for the demolition and also the contamination. This is the biological cavity that would be in those places used to have higher activity. And this you can see here the marking you need to have inside for checking, the contamination of each walls and each, the contamination, if there is contamination inside. This is the soil. The soil decontamination plan is already running, still running, because there are some, they are treating the soils. So they need to reduce the amount of radioactive material to be sent to El Cabrón inside the acceptance criteria that we have. And this is the current situation. It's almost demolished. It's strange. It's like this. And some conclusions very quickly. So we have backend integrates the commissioning, dismantling, waste and spent fuel management and disposal. The strategy depends on fuel cycle and reactor technology. The immediate dismantling is the preferable strategy supported by international organizations. The commission is a very multidisciplinary and complex activity that involves many disciplines with high investment and risks. These projects require specific professional skills. And it's a build to dismantle. Yes, build to dismantle, because you see that we needed at that time to redesign a building just for dismantling. So you design for dismantling. So there are a lot of engineering activities, bespoke engineering activities, in fact, tailoring of the specific activities of engineering in this kind of projects. Also demands important resources and a robust supply chain. In the case of Torita, during the highest movement in the site, they were working more than 300 people, workers, which is a small plant, just only 160 mil. So it means that there are important things to do. The plant is in operation, still in operation, not in operation with power production, but some of the systems should be working, should be running during that time. And the risk is reducing. I mean, safety will be always have an average that you need to comply, but the radiological dose will be reduced with the time if it is everything is done correctly. The Spanish case has an extremely tight scheduling. 7 remaining reactors to be dismantled in starting 2026 to 2035. So it's a government decision, and we will see the reality, because it's almost impossible. 7 reactors in so short time, but we will see. And waste management strategy is already fixed based on the operation of the Cabrit facility and the CTS, which is centralized temporary storage, which is in project, but probably will not never be. But what is sure is that there will be an IS5 at full capacity per each site. It will be for sure, because it's already in purchase process, the new castle and the design of the new IS5. And also, it's interesting to say that the nuclear legacy should be optimized in the backend strategy. So would not be considered enough having the decommissioning as money without optimizing the costs and the scheduling and the ways that we are going to live. And finally, for Jose Cabrera, what was the lesson learned? The first, the structure, organizational structure. Again, before we see from Bayana, interesting presentation about project management. Project management always depends on the people. Without people, it is not possible to manage anything. And in this case, there was a lesson. So the organizational structure of the operator should be fitting the new situation and will be changed during the time. The design modification procedures must be simplified. That's very important because those sometimes spend a long time from the operator to the regulator, to the regulator to the operator. So those things will be performed before and within after. The fluid communication, always, not only with the regulator, fluid communication will be with everyone. Radiological protection becomes more relevant than nuclear safety. That's important, interesting. So radiological protection becomes more relevant because nuclear safety, the systems works and are designed to be safe, and you only need to make some changes. But safety, nuclear safety should always be fine. But the radiological protection is always an issue because everything is new, and sometimes, in some cases, you are facing new things. Full integration of operating personnel, very important, this matter. Using mobile and modular facilities, if possible. And again, there's something, this is words are coming from a colleague that is to say, radiological characterization plus radiological characterization plus radiological characterization means every time radiological characterization. Don't forget. And finally, we need to have a volume reduction and cleaning process well defined with checkpoints. So that's it. I don't know if you have more questions, but I spent 5 minutes more. So
Thank you very much.
thank you.
I would like to make an announcement. Concentration, this is about our plans. Unfortunately, today, tonight, we will not have our excursion. Because of rector, who is the head of our university, has planned an event for today at the same very place where we expected to visit. So at the moment, we are working on transferring this excursion on Monday, right? And we hope that everything will be all right. So please don't get disappointed. I'm so sorry for this inconvenience, which is actually beyond our competence. And thank you for taking your passports, however it was conveyed. Please have them for tomorrow, okay? And I know that some of you have 2 passports. Please have both for tomorrow's visit to office. And please come to have your tokens for. Да, у нас же
We need to find some solution because this equipment are pricing very expensive. So one thing is some solution for such equipment. Okay, for split view, also Can treat the radioactive waste, or like since we were
You mean
use
you
it.
need to reuse the reactor vessel
In some instances, we have so much that already are radioactive. But
to use it for the plants?
to use again, or at least remanufacture.
They are not consumed in the kitchen.
Okay, so it will be stored forever.
You can do what you can do. You can move it as a whole and store in something. You can, but the reusing is impossible. Nothing is impossible.
I completely agree. It's more tasty. Storage. Okay. Find place. Spreading more. So we need to minimize the waste. Store the waste. I think this is as a lot we need to find a solution for such
If we do reuse it, it will be an advantage.
yeah.
But the problem is that usually, depending on the time, something that there was an accident, and we have 3 generations, and there were not many hours of running. To reuse that. But again, we need to have verification that it is possible to use
Minimize it, at least.
in the United States, what we used to do is that we have some places to store these people. But the use of all the equipment is not good.
Yes, reducing. Use them convert the radiation to electricity, like in batteries.
Yeah. Reprocessing, you know that the problem of reprocessing always is the weapons. Because when you are using reprocessing, you could have the possibility of weapons. So weapons, nuclear weapons. So you reprocess, you can have the option to create weapons, to manufacture weapons. You understand? Nuclear missiles. Okay. And then, for the things that it is not easy to do it. But easy to do it, yeah. There are some reactors, some SMRs, they work with computer. They reduce a lot the waste. Like the big reactor. I think you can have some information from GE, for example. General, as an design for the precision plutonium. It's more good. So we participate today with the molten salt reactor
Canada, molten using also reprocessing. Yes, I have made a before complete proposal about this idea. These batteries recycling waste and without discharge as well to the plant. By using 2D nanomaterials and like metal electronics and so on. I am so interested in this.
Yes. No, but I cannot tell you too much. But I think everything regarding
This is related to a new generation.
Okay. I cannot, with radiochemistry, I'm not an expert of radiochemistry. Only friends. Thank you very much. Thank you.
I want to shoot
No problem. Vertical only happen in the Russian side. BWR, and I think they are not using in the new ones, they are not using.
It depends on your level.
For me, in a power water,
I have never given it, I finished my last test, I'm afraid 4 years ago. So I cannot, you cannot give it.
We have more than 10 minutes, and we can work a little bit more with the.
Yes, we have to arrive approximately within 3 hours. So I believe, okay, what is your airport?
Yeah. But, for you, what I mean, just check what the people are doing lately. It used to be.
Everybody stays till the
You see, for
afternoon, yes,
example,
right, exactly, and some people do
latest
leave
people
earlier,
you watch, it's gonna be
I already designed, I finished it. I can show you.
So what?
But with yes, I already finished it. But with the water,
The matter.
and if I choose vertical, maybe vertical without economizer.
So, if you don't mind, yes, so I
sequence, we have
so maybe you'll have the lunch, right? And after that,
this is a vertical.
but please, wake up and just to have
Vertical one
much
is vertical also.
and I also will plan to have it stuff with us.
For me, seems more logical. That is one. Just the point is not what the industry is doing.
I believe that.
We go to a new reactor, they are not using, for example, EP 1000.
So I have some ideas from here, right?
I don't remember exactly, but I think they have read
That long till we go
It's a
through,
passive
right?
system.
Up to the schedule, right?
but they
And
used to
give,
work
bearing in
vertical.
mind that, what is this?
So if I do this silent,
So our, our gas.
I work in this situation, I will do it. With the measure and all the phases that
Right.
yes, but you have the
And depending on that, I can advise, right?
the
What is
outlet
better
and the generator
from one country, for example.
saturated.
Anyway, I believe that you might come just for 1 hour, for example, and then thank you.
I hope I answered your question.
Например, так,
Thank you very much. You mean some scholarship or company because you like the tools we have was to make sure you are scientific. Definitely you can work in because it's needed scientific view.
Guys, the plans have already once again changed.
There are some different parts of the project. One part is more related to specific calculation, codes, and scientific knowledge is also required for a conference. Working with us.
Once again, what you will do, we will come to the main.
And we only need
to the very outside.
answering your
special
question.
Place on the top of the main building. And this is not the
If you like
I have believed for 30 years of my life with it.
No reason for change, because they will need
Because right?
We have people
And you know, that's
very
why
scientific.
it's not that easy, right? So we depend
Well,
on
they Why are they storing
Mathematics, but we also have a lot of needs. In my experience was that we need a lot.
I have to
But the way of work is different.
First of all, we depend on
I know from the university to the company.
right?
Different.
And depending on
There are
the
some
strategy,
adaptation of the way of working.
for example, we have changed mind, and we will not come tonight.
So I know.
So if
The environment of working environment is different. Different company and universities. But
Yes.
someone wanted to be
Right? So the first
involved
group
with
will
the
come and we'll go there. That's why we will stay with us.
we have another.
It will be 4 groups.
So I need to go.
Is the one who gets there.
the question of money.
What makes sense to
Yeah.
say that?
No,
You
you're
will
right.
meet me there.
The first time we didn't go.
To also
Okay,
what
so you
connection?
will go back and forth with the person in the second group,
Money.
right? And you will, get
Company will
invited.
pay.
You will make
Companies will
invited
pay.
to go to there, right? So you will meet here with them, and then we will go out.
So you changed already.
No,
Again.
we did, but that's not us.
Yeah.
That's the rest.
Are you just here?
No, I didn't go to the last.
Okay, exactly. So this is the actually
Most nuclear industry.
main person.
You are a good expert, for example, radiochemistry, radiochemistry, radiological characterization,
And to reach this
which
place,
are,
we need
because there are not
to
many
get
experts.
special
You need an expert
person and
working
change
project
this plan.
related
He's
to
supposed surprisingly to be
commissioning
there in the
with
match, right?
radiochemical
That's why
characterization,
we
radiochemistry.
had to
You know, there are
cancel
many
our
things to it.
visit. But again,
But
we changed
they-
plans by some reason.
Everything depends
right?
on
And now
the number
back,
of
we have this
people that
opportunity to
has
come.
this expectation.
That's it.
If there is
Even
not
it's
many-
not that
many
easy
people
getting
do
at this very place. Then we
less,
can
no?
do it like this, right?
But if you
We
you are
should
working
use the
with this and
opportunity
there are
now,
not many
because,
people to work with,
you know,
You will-
on Monday, we just remembered that
If you
Monday
get the
is
special-
our,
for example, we used to
so we cannot combine one with the other, right?
having this
So that's it.
characterization,
No,
which
not
characterization,
because on Tuesday, we
know
have
how
lots of
to
people,
manage
they
this,
leave
how to classify them.
on Wednesday early in the
What
morning,
we
for
do.
example, and we
And
decided.
it's not easy,
to have
at least
our
in
meeting
Spain,
on
to
Monday,
find people
because some of us, they leave
has
on.
the experience in the commission.
Somebody.
Depends on the
leave
country.
Tuesday,
I
right?
think Russia has people.
So, never mind. Us, we have a few rules, right? So,
Still those people
that's why we decided that it's
don't
better
like
to
to-
meet on Tuesday or on Monday,
to
right?
involve in.
Because Wednesday is the last day, lots of people are living on Wednesday, right? And some of them have to go first to the office, have 1 hour lecture and then back. So, and I, before, on Tuesday, seems to be a bit risky, this particular. Okay, so apologies for these changes, but you know, this is beyond our control, right?
Now it's clear. I'm working with
Ахмед, ты бы дал человеку пообедать?
Хорошо,
Потому
да.
что у нас в 2 часа начало.
Okay. Okay, thank you. Thank you. So we will look at all later.
Ahmed, have you got this talk?
Hi. Hi.
Hi, nice to meet you. Sorry. Sorry. So, thank you. So just to advise you, this is a token of a ticket to our canteen. If you would like to have your lunch in there, I will escort you there. So the limit is mentioned in here. This is 350 rubles, which is approximately fixed for 2 dishes and a drink.
Enough.
Great.
More than.
Okay.
Okay.
So let's go.
I think I will see you before we tomorrow.
Exactly. So yes, you're leaving tomorrow. We've
Because I
been
don't know what
yes, we had been discussing with our person in charge of your transportation back to the airport. What time do you prefer? Because your flight is 8:30 exactly. Right. So we given you're leaving from Sheremetyevo, I suppose for you to have your taxi at 5 a.m. Is that okay with you? 5 a.m. because you have to arrive approximately, you have to arrive approximately within 2 hours and a half, 3 hours before your flight, right? And the airport is on the north that you can spot, and it might take you up to 1 hour and a half to get in there. So to be on the safe side, given you are depart at 5, you're arriving there approximately, 6:30 more or less in the worst case, right?
Okay.
And you are coming just within 2 hours in advance, right? So I believe to be on the safe side, 5 a.m. sounds reasonable, right? Okay.
Are they going to pick up me?
So we will send you the details of the driver, and definitely the driver will have your mobile number. I'm not sure about his English.
No.
But at least if any troubles, right, please give me a call and I will arrange and I will.
5 a.m.
No problem. I'm always online.
Okay.
You're welcome.
Thank you for your support. Okay. Sorry.
I will be downstairs to escort you to the canteen, but by the way, maybe you can show. Okay, so I believe that your friends, your colleagues will show you how to get there, okay?
Thank you.
Так, ну что, пошли.
you don't have to sleep. You know?
Maybe for the planet, maybe
How long?
Yeah.
How long? Do you,
5 hours.
5 hours. For me, it's 3 hours.
Just think it. If you go to our
It's no continental flights, but
maybe not in the at the time, the final so, 1, 2, 100.
this minute.
But it was really good.
Thank you. Thank you very
Maybe
much.
one of them was the best one.
I think so. Really was the best one so far.
It was more,
Thank
more
you. Thank you very much.
more practical than
The best one, you know. No, was I tried to give some experience. Yeah, because that's why I run very quickly here because I wanted to talk about. Yeah. Sorry? Just alarm. Encima, ele tá agora ele tá bom toda essa nada como como isso como a joga set sanam saya kalau itu bukan sih saya kalau just habis mesti nyobi nyokai nyokai kota itu tahu yang soal saya mau ada kesalahan kita waktu lagi pada awal kayak waktu oke ambil itu mati tidak mau buat buat semua itu sih program itu aja lo nilai atau video beli lo tak cek Letztendlich si tiene una confusión o hubo los pasos que usaban que ven o una que o una que también no pasos o sea o uno jugando uno que yo para los tamaños em muito eu comprei hotel com estudo na via mas já não tô você também quando uma mira no Pero tú sabes que lo que va a pasar, que estamos pescando, pues como de, nada de cosas, y no tú ves ni que más más no no ni más que cosas poner las cosas, poner poco tipo de comprar y yo soy un más. Una vez cuando vi una de mà bây giờ tôi biết tôi đã tầm xong với các bạn nhiều có ám của những về hôm nay xem các buổi đang được sáng chúng ta cũng muốn không phải không phải siêu đây okay. Just sound. Okay. Let's have a think about. So, yeah. Which message? Ooh. Okay, it's already on the table. Yeah, apply for the contract. If it's coming on already. It's coming with cookies and anytime you send message, we didn't put anything, I hope this one just was allowed. We didn't write any message, just allowed. One will not know. No, anytime you just send a message, I want to send a message, I will see it and I'll reply. Hello, for Lord, only send salam. Even if I was if you send me when I wake up, I will see that I will reply. You understand? You understand that kind of thing? You just make someone to be thinking of what they're trying to say. So, yes. All right. How can you help me? I help you by talking to me. Hmm? Well, me, I'm not in one of them. So, let's do it. So, program. I'm just if you spoil to passport time. Let me just finish this one. Yeah. Finish this page here. But I'm not don't cost me. I'm not telling you how to do it. Think of something like that. Well, I'm looking. I'm very optimistic. I'm hoping. I'm very optimistic. Wow. It's really painful job. Somebody from Sweden. The work is all. The Mika already applied a lot of things. She's a well-known school. Or sometimes postdoc mula postdoc volunteer increment per analytic we have 6 months, sometimes 6 months. One can apply. Just send my CV. How much another? Now send message to me. When I send message to me, so adequate and sufficient for me to take me one day. They wants to understand my condition. Wow, provide the not November that we one was the call we speaking science from the side. No, but you know one that's total opportunity now. I need to think about it. I don't know what we are going to discuss on the podcast. Inshallah. I don't know. It's like why like don't make it focus. Maksudnya gimana? Ya, contoh jadi yang beda ya. What to do for you will not pass you. Yes, our habit to accept that my development.
He said he doesn't want to play with us.
No, yeah.
Oh.
Yeah, my daughter doesn't depend on application. Only so one class. I think in my own opinion, I think it's meant to be that once you something because we don't have a lot of our future should not try to have but I don't know okay, they do not after striving and praying, do not get it. I know that our future is our and I think that's a picture of the salaries. I think that's the picture of the and to the best of my idea, that's teaching of that's human being. You have to see the because I'm not paying you 6 months time. What question? But advance. That's what I don't know. It's actually you'll be thinking back, kind of. It's really, but we think back as the middle was in one put in the. It's not really that good. That's true, yeah. I'm not in there. That's because now it's for 4 years. Now it's going to be more than 4 years. It's going to be more than 4 years. Now I'm telling you, it's 4 years. I'm not very much for 4 years. It's not now we are understanding better. Okay, that 4 years, actually that 4 years, now one shows you have completed post-war and everything that you have submitted so if they are not satisfied, yes, that by that September.
Demek ki bir şey olması gerekiyor. Üstten bir kadın rektör olması gerekiyordu.
Não, e aí não vai por muito, já está. Eu não fiz que todo so at least ask this one to it.
Zaten ilgili aslında.
Oh, yeah. When in Korea, they take you point and so even though that person has been everybody has been if I'm not telling you the context that because you have to take on big personalities, so not in my opinion.
Was the school? Right.
When I that's the way when I took the but also well, what to say?
What kind of stone?
When I compare it.
Okay, I see what you Yours from slide.
Long sleeves. Everybody has some short sleeves, some t-shirts. I'm not coming from home. I'm coming from you. I know what you want this. I know what you want this. No. I don't want this. Very fast. No question. I see. Intentions to be done. Is it tough? I just
No, it's not. No, it's. No, it's very.
Okay, they are stronger than Russia. In Israel,
Like 0 degrees, like right now, it is solar energy. And then in Russia, it's cold. I every year in Russia, I've been to like 2020.
this time I also asked. Find some appropriate for the next person. What is this for?
Engineering.
Then for my 9 years period, nobody will complain that that's a good idea.
But it is good because everyone will remember it was weird. And everyone will be like, remember this one.
Some extra money they expand. So
For everyone to play the code.
and you just
Or maybe a code like with Rosetta, for example.
Да.
Так, а звук у нас где?
Ну, через камеру.
Понятно. Хотите слово говорить?
Да. So, dear colleagues, we'll continue with the next lecture that will be given by Dr. Sergey Mikhatin from Institute of Inorganic Materials, who is an expert in decommissioning technologies and also worked in Bulgaria.
It was time, yes,
Yeah,
for years.
So they're really expert in decommissioning with real experience. So please, Sergey.
Hello, everybody. Today, in the next hour, we will speak about decontamination, different decontamination technologies which can apply for decommissioning purposes. I am Sergey Mikhatin and working in a nuclear industry more than 40 years. Last 30 years in development for decontamination methods and decommissioning technologies for application in the Russian Federation, and as Vladimir said, for years I worked also for Kozloduy nuclear power plant decommissioning project as consultant. Now I again working in Rosatom. It's VNIM institution. That's a big research institution which produce different technologies for nuclear purposes. And so we have a lot of contaminated facilities inside our research institution. And it is located just only in 7 kilometers from Moscow Kremlin. So it is very difficult problem for us. And within the last 2 years, our institution included into the structure of centers of excellence, decommissioning centers of excellence of 12 companies. 12, it is a few companies for nuclear purposes. So let's start our discussion. Sorry.
Ага, все, теперь пойдет. Сейчас, секунду.
Okay. So everybody knows what it is washing up process, and every day, everywhere we can wash our hands, our dishes, etc., etc., and we can compare the contamination processes with simple washing up processes. But here we should remember that if we meet the problem of contaminations with fats in the case of our dishes, washing up process, but for the contamination we have problems with radioactively contaminated materials. So the safety is the first what we should remember within operations with under the decontamination processes. And second differences from simple process of cleaning up of different materials is a very strong contaminations, because practically all radioactive contaminations which need to remove before the decommissioning of different sites. This sites operated many years or even 10 years, and so all contaminations are very old contaminations and fixed contaminations. So we should apply very special procedures, very special methods for the contamination of radioactively contaminated materials. So what it is the contaminations? It is definitions like it's recommended for EAA. So decontamination is a complete or partial removal of contaminations by a deliverable physical, chemical, or biological process. So you can see here the three possibilities for decontamination: physical, chemical, or biological processes. In the normal practice, usually applies as physical and chemical procedures, because biological process is very
complicated and not have a good results, good efficiency for the contamination. So when we can choose the different technologies, I should say that we have not some universal decontamination methods, because every time we have a different contaminations, different possibilities for decontamination. So we are not, they are not universal method for decontamination. And so every time when we will have a problem with decontamination of some facilities or some laboratories, some equipment, we need to discuss different opportunities to apply different methods for decontamination. And so the first problem in decontamination is a safety problem, as I said already. The second is efficiency. What is efficiency? It is efficiency, it is the decontamination factor, practically. I will say it's later about this problem, because cost effectiveness and efficiency, it is practically the similar things, but efficiency, it means the physical processes, how many contaminations we can remove from the surface, but any our activities has a different cost, and so the decontamination is a really economical process, because if we can in ideal system we can decontaminate everywhere and everything, but with 100% of efficiency, but in this case we will pay so much money for this process, and so we can remove these materials without decontamination in this case, because you understand that decontamination can reduce some activities from the surface, and so we can reduce total activities of this contaminated material, and so this decontaminated materials can use for unrestricted applications if it's reach the contaminations and limits for free release of these materials, or can reduce the type of contaminations of level of contamination. So we can reduce activity of this radioactive waste from high level waste to intermediate level waste, or from intermediate level waste to low level waste, etc., etc. And so you all know that low level waste management with this low-level waste materials less than cost for treatment, for example, high-level waste. So we can reduce money for management with this different materials, and so if this money will be so high, or so much money we should pay for decontamination, this process will be not reasonable, so we will not produce it. And the next moment is differences of decontamination methods, because decontamination can apply during the whole life of this nuclear facility, starting from the first service of this equipment up to end state of these facilities before shutdown facilities, before decommissioning. So, but difference is very simple. During operation period, we can apply very soft methods of decontamination. Why? Because anyway, this equipment after decontamination should be operated for its normal operation. So we can remove just only small parts of contaminated surfaces, and we can remove only small part of metals from the surface. So we limited it with only with very soft decontamination methods. But in the case of decommissioning, we can apply more strong materials. We can remove more materials from surface. We can remove, for example, not only 10 or 50 microns from surface. of metal surface. We can remove up to few millimeters of even centimeters of surface, but we can decontaminate these materials for reduce its activity, for reduce its volume for next treatment with like with radioactive waste. So this is main principles of decontamination. So, choosing of decontamination techniques depends on many factors. For example, the type of contaminations, type of facilities, type of equipment, material for equipment, the history of these facilities, many factors. And so this is a multi-factor analysis when we apply, when we should to choose the right decontamination methods. Main factor which can inform about the efficiency of decontamination is the decontamination factor. It is well used data about which can characterize this efficiency of decontamination. The decontamination factor is the ratio of activity measured before treatment to activity measured after treatment. So in the worst case, the contamination factor is 1 if you cannot remove activities, and high the contamination factor can be thousands or more. This depends on the final state of the surface. So normally we can use different application of the contamination factor. So what it means, the contamination factor is 1, it is no decontamination. The contamination factor is 2, it is it means that we removed 50% of activity, etc. And so you see in this table all information. Also, we can meet in some different sources. It's also a residual factor, efficient characterization of efficiency of decontamination, like the different terms. And so, but mainly very often we can meet main factor. It's a decontamination factor. Some examples about required decontamination factor. So when we talked about very soft materials for decontamination, we can apply we can remove just only upper level of the surface, only few microns of surface. So we can have only a small amount factor, decontamination factor. But in the case when we need to decontaminate finally this equipment, and we don't need its restart for next application, we can remove more materials from the surface, and so we will reach higher decontamination factors, higher efficiency. So what the contamination is removal of contaminations from the surface. So you see different decontamination methods subdivided in the dependence of its nature of this treatments of surface. So we can remove this with water or abrasives. We can dissolute this contamination with oxide layer on the surface of metals with different chemicals. It's quite like in the stand. We can remove surface contaminated, not fixed contaminated, with different surfactants. Okay. Also, we can remove contaminations with application of physical and chemical. That's a mixture of different methods. We can remove just only applying with application. Different covers, like here it is strippable coatings from polymeric films or polymeric gels, or we can mechanically treat the surface and remove this upper layer of surface. Mainly it's applied when in the case of high level of paints, or very big layer of paints on the surface of metal, or for scubbing for concrete surfaces like here. So here you can find the all list of the contamination methods. Yes, its presentation will be distributed. Okay, so you will have this list of the methods of the contamination. This is practically full list of the contamination methods, but in red you can read this more applicable methods, and now we will discuss about these methods, methods. First of all, before the discussion of the contamination methods, we can understand how materials has received contamination. So the nature of contamination, because when you will understand how material was contaminated, you can offer the right decontamination methods for this material. So normally and very often, contaminations includes into the layers of sediments on the surface. Sediments, it's very different. It can be sediments from the water media or liquid media contacted with the surface of metal. Also, this contaminated media can comes to the level layer of oxides level. So, and in this case, penetration of contaminations can be up to level surface surface of metal. And in the case of very strong contaminations, as a result of decades of contaminations, contaminations can penetrate even into the metal matrix, into the deep of metal. So we can remove different layer of this contaminated surfaces. And so remember this picture of penetration of contaminations and how we can remove this deep of metal surfaces. We can reach a good efficiency of decontamination. How looks this contaminations and contaminated materials? This is example of crusted materials. It's from sediments, from this, from evaporate, from evaporated tanks, which operated many years, and so you see very different materials. It's a very different color of materials, very different structure of materials. So it is like, it looks like mineral, it looks like amorphous material. So it's very, very different materials. So we need to remove it. And for the contamination, it's very important how contaminations interact with surface. It is energy. It means that what amount of energy we need to spend for removing of this contamination. So we have two kind of fixation of materials onto the surface. The first, it's very light contaminations. It is physical sorption with the energy, with slow energy of interaction between contamination and surface. Practically, it is just only sets like dust onto the surface of materials. So it is a low energy interaction or chemical interaction when this contaminations fixed in the upper layer of surface. And so for transporting of this contaminations from the surface, we need to spend very high energy for destroy these interactions of these contaminations with surface. So what kinds of composition of deponents? It's very important for when we will speak about the chemical decontamination. Usually this layer of contaminations. Here you see this is oxide layer. So depending on the nature of metal, which we have inside this our equipment, we will have a different materials we need to which we need to remove. It's nickel ferrite material compositions for in the case of application of nickel materials, or magnetite in the case of when we have a carbon or carbon steel or stainless steel materials. So depending on knowledge about materials onto the surface, we need to prepare the different decontamination methods. So the first decontamination methods we will discuss, it is chemicals. It's traditionally applied for many facilities. Practically, this method is the first is decontamination methods in the history of development of nuclear energy. So for this purposes, we can use the different detergents, exit solutions, alkali solutions, mixed redox materials, foams, strippable coatings, gels, and even molten salts. So in this case, we will remove all media which are contaminated with contaminations, with radionuclides. So we need to dissolute or remove this media as a result of chemical reactions. This method is very good for different purposes. Why? Because we can, with application of different chemical methods and different chemicals, we can prepare the no soft chemicals or mild chemicals, which not includes the very aggressive acids or alkali or oxidants, or we can apply aggressive chemicals, which can dissolute practically all sediments onto the surface and different kinds of surfaces. So it's very flexible method. We can apply absolutely different additions for the water solutions or some organic solutions. It depends on the treatment needs of this treatment. Very often we can use the combination of methods. For example, the first we can apply alkaline methods, which can prepare surface for treatment. During this alkali treatment, we can remove some fats, oils, or organic contaminations from surface, which can protect surfaces against next treatment. And the second treatment is the acid treatment. In this case, and on this step, acids will dissolute metallic surface or oxides of metals up to metallic surface, and we can remove all contaminations from this surface. So you can meet or prepare the very special methods. Can we apply not only 1-2 methods steps, but we can apply many steps for different purposes. So it's very good for flexibility of this method. It's very good for reaching of very high efficiency, up to thousands of the contamination factor. Here it will be up to thousands, and in combination of different chemicals, different chemical reactions for different initial materials, you can prepare the different compositions for decontamination. So it is a next example for removing of chromium from stainless steel. So how we can apply these methods? Because it's very easy to apply some water solutions for any surfaces, but for industrial application, we can prepare the special facility or special site for decontamination. Why? Because anyway, you need to organize a very strong ventilation in this case, because all methods, especially chemical treatment, will have high speed of treatment with high temperature, and the best effects will be temperature. It's approximately 90-95 centigrade. So in this condition, you will have a very strong evaporation from this equipment. And so you will prepare this very good ventilation system with treatment of secondary waste. Also, all these tanks or big baths should be prepared from corrodively stable materials. So for like stainless steel or very special alloys. And this industrial facility should be big enough for cutting, for possibilities to applications equipment for big fragments, because it's very easy to cut big equipment for big parts, but it's very difficult and very expensive and very big time needs to cutting for small parts. So normally it's prepare this chemical facilities as big as possible for your needs. But it is different applications of methods, because the first this slide discussed possibilities to decontaminate equipment after dismantling and fragmentation for small parts, but in few cases you will need to decontaminate big equipment without possibility to cut it or fragment it for smaller parts. For example, for the contamination of evaporator, of heat exchangers, or the contamination of equipment from the primary cycle, like here. For this purposes, you will need to prepare the special pumping system, which can rotate water and chemical media inside equipment, your tubes, valves, tanks, reactor or heat exchangers, etc. Looks like here it is this photo making the Bogunitsa site for, and this equipment is applied for the contamination primary circle of this reactor for OVR 440 reactor. For this purposes, you can organize this engineering system like here, this machinery, and apply different chemicals for decontamination. I demonstrate here just only more popular methods for decontamination, but normally it's operated for operation system, but not for decontamination purposes, because it's relatively simple, relatively soft materials. Lomi process also characterized for decontamination. It's very possible applied for decontamination of inside before dismantling of equipment, and the decontamination factor and time of treatment. You see that the decontamination factor in this case can vary depend from treatment time or period of treatment of this equipment. If you need to have a very high efficiency of the decontamination, we should spend a lot of time for this purposes. So this next application for the contamination method. So it's duplicated. So it is more popular methods, and the contamination techniques are widely applied for the contamination purposes. So you see, depends on location or depends on the nature of equipment. you can use different methods of treatment. So it depends on different companies that develop their own processes, and so apply these processes depending on needs of facility or site. This is a list of, so I will not discuss in details a list of the decontamination techniques. It is different reagents, different combination of chemicals for decontamination. The same. Also, this is in this case you have a description of chemistry of this process, but here it's includes just only name of processes, and you can find it's depending on different companies which apply it for decontamination purposes. So, for summary of chemical decontamination processes, we can say that it is a very effective method for decontamination. It's really very suitable for materials with different geometry. It's very pliable for both, like from the internal, like external surface of the decontaminated materials. And it's practically not depend on size of these facilities, but if you will apply very big and very big capacity facilities for decontamination, we will produce the very big amounts of secondary liquid radioactive waste. And very important that this radioactive waste will be very aggressive. And if you know, for treatment of liquid radioactive waste, next steps of treatment of liquid radioactive waste is evaporation, cementation of treatment of some different matrices. But in all these cases, chemicals will be very bad for next steps of treatment. So because, for example, cement matrix can include just only few percent of in volume of highly salt content materials. Also, it will be have some chemical reactions with acids, so it's not very suitable. So this method, all chemical methods very apply now for very special purposes, but all other methods developed for minimization of amount of secondary liquids. And one of the important and very easy methods for minimization of secondary liquid waste is the application of surfactants. What's the nature of this methods? Practically, you can combine chemicals, not all methods, but many chemical compositions and detergents. As a result, you will have the very big amount of foam, but volume of foam, but with a very small amount of liquids, because if you have very high degree of foam, in this case you can transfer chemicals or transport the chemicals to treated surface, and don't use the practically all volume of treatment equipment for this purposes. And in this case, you will deliver chemicals for treatment up to surface treated surface, then waiting for some time, for some period for completion of chemical reaction, and then you will accumulate just only small amount of liquids, which can place it on this metal surface, and you will accumulate it, and then treatment like this liquids, but with just only a small amount of liquid. So this method is very good for application, and our institution applied very widely and developed the special methods and special equipment for this purposes. You see, like here, it is the contamination of glove boxes. You don't need the input all these glove boxes to the treatment facility. So amount of this foam after the collapse of this foam, it will be small amount of water and liquids. So this is very big advantages. But of course, after treatment, you will have problem with secondary liquid waste again. You can accumulate this foam and rested liquids with some materials, but it's not very applicable for many countries. Because, for example, in the Russian Federation, we can use only cementation method for solidification of radioactive waste. So cement matrix and foam not combines very well, but it's better than includes a lot of secondary waste in case of chemical treatment of surface. Next combination of chemical methods and physical method, it is electrochemical decontamination. This is a combination of two treatment possibilities. It is dissolution of ions from the from metal surface and electropolishing process, which will be remove metal surface from this contaminated material. So you see, you can remove some surface for depth of approximately 10 or microns or more, and remove all contamination. In this case, we can. Oops, I'm sorry. Many methods. So we will accelerate. I'm sorry. No, but not so quick. Not so quick. So back up. Yes. So it is application, but here you can apply this. Also, you have a two-way for application of electrochemical decontamination methods. You can apply its base or volume of tanks and use it like a normal chemical methods, but also develop this very special external electrodes can operate like electrode area of treatment with a small amount of water media, but we apply the electricity from the surface and electrode or rotated electrode. It's very effective methods, and we develop. So it is yes, examples of bases or tanks for application, electrodes, and application of experimental model of rolled electrode. So next combination of water and chemical and physical treatment is application of ultrasound. Effect of ultrasound includes coatation of small particle of bubbles near the surface. In this case, the surface will treat it, metal surface will treat it with very high energy cracks after collapse of bulbs. And so all compositions, you remember, oxide layers will be destroyed on the surface. Ultrasound, which very suitable for application for very big differences, different design of methods. So you can apply it for small tank, or like here, it's not radioactively contaminated material. It's wagon wheels from railways, and the volume of this tanks is practically 20 cubic meters. So it's very possible to apply it for small and big. Sorry?
The meter supply.
What's the mechanism of the ultrasound to reduce the contamination? How is this?
It's operated, I demonstrate here. Look at please. This after collapse of small bubbles, you will have very forcive crash of these bubbles from the surface of metal surface, and this colloidal surface layer will be destroyed, and the surface of metal will be clean. It's just a mechanical treatment of the surface. But if you will combine it jointly with chemicals, you can treat both like chemical methods and destroy the surface of colloidal layers. Just only destroy. We will meet these methods of application later in laser and in dry ice treatment. So next method of it's also chemicals, because we can apply methods of polymeric film application of polymeric films. The polymeric films normally treated prepared in the like water solution. It's usually norms used for this purposes aqua solutions of polyvinyl alcohol, which are very good for application, because after application its forms on the surface polymeric films can be removed, but during the period of formation of these polymeric films, practically during period of drying up of these materials, you will have interaction between chemical solution, because you apply it from liquids. So liquid media, and so this media is very suitable for chemical treatment of surface. But after treatment and polymerization of polymeric film, all this dissoluted chemicals and dissoluted contaminations will introduce into polymeric films. And the polymeric films will be removed jointly with contaminations from the surface. It's very easy, it's very good, because in this case we have no liquid radioactive waste, secondary liquid radioactive waste. It is general composition. It's a lot of variations. So you see here, after polymerization of this thin film, it is stale, very contaminated with plutonium-263, 239. And when we removed this polymeric film, it's removed also with contaminations with oxide layer from the surface. It's very important, because in this case, so it's very different applications. It's very possible for polymeric films, and we remove it with just only a small amount of secondary solid radioactive waste. So it is a view under light microscopy, removal of this treated polymerized enforced polymeric films. So you see this all contaminations includes inside this polymers. It's just only a next example. So next variation of this methods of polymer supply application of polymers to decontaminated surface. Application of polymeric gels. This technology developed initially in France and the United States in Argonne National Laboratory, and applied for decontamination of different kinds of surfaces, not only metal surface, but also concrete surfaces, like here in former hot cells. In this case, polymeric gels also treated from liquid water solution, and then after polymerization, it can destroy itself, and after then accumulate just only very easy system of vacuuming, like vacuum cleaners. So it's very good technology, and
Now we develop the next generation of this polymeric gels. And the last example of the chemical methods, it's molten salt, the contamination with molten salts. The nature of this procedure is the solution of contaminations in very complicated composition of molten salts. It is a more exotic method, but it's very applied for small parts of very contaminated metal from after contaminations, especially with uranium and transuranic materials. But it's a very complicated method because it's need to keep a very high temperature, and as a result of this high temperature, I'm sorry again. We will have problem with treatment of secondary gas, which can include also different chemical compositions. It also will be very chemically aggressive. So next group of decontamination methods is physical decontaminations. This very simple picture demonstrates how you can remove this contaminations. Just on the application of this force for non-fixed contaminations, like physical adsorption, or you can remove these contaminations incorporated inside this oxide layer. So main advantage of this method, so this kind of methods, is a very small amount of secondary radioactive waste, because really we have no we don't add to this the contaminated media any chemicals, just only abrasive in the case of abrasives, but in the negative part of this methods is a very big amount of secondary air, contaminated air, because anyway you will need to remove all the contaminations which small aerosols from this for after treatment. So you will need to remove it from the surface and then treat it properly for safety reasons. For this purposes, a lot of different kind of equipment already developed. Very old equipment was like here, it's from American market, and now applied even for the contamination in Fukushima site. Anyway, it is a combination of a mechanically aggressive mechanism, very different design, which can rotate under the surface and destroy the surface mechanically, and then immediately evacuate for vacuum system. And then vacuum system will be accumulate this contamination, this all aerosols and crushed parts of concrete, for example, accumulated, separated here, and practically really in the drum, ready for storage. And after treatment into the HEPA filters, air will be removed for drops for environment. So idea is to combine mechanically aggressive mechanism with immediate evacuation of aerosols and crushed materials from surface. It's very different applications and very different designs for its application for this purposes. Here also it's possible to use some needles can broken the surface. In this case, you can treat it just only plain surface, but also some different болты, не помнишь как? Screws, yes, sorry. So you can treat it very well for the next
Next method of mechanical treatment, it's also produced also liquid radioactive waste, but very in small amounts. It's water jet, application of water jet. The system is the same, the nature of treatment is the same, just only treatment the surface with kinetic energy of this jet. But here you can result it just only small amount of secondary water, contaminated water. But in the case of not strong contaminations, you can recycle this water for many times. Next application, it is application of abrasives. It is steel pellets or corund materials which can treat the surface also with high kinetic energy, and then remove all contaminations with upper layer of treated surface. After treatment, you should collect used abrasives, and then you can recycle this if possible, or send it for treatment for storage. A very interesting variant of this version of mechanical treatment of surface is application of dry ice. In this case, we can combine not only we can combine kinetic energy of these particles with high speed delivered for surface, and the surface layer can destroy it just only with as a result of high energy of these particles. But also, very cold particles of dry ice will produce a local frozen in this part. So it's very quick frozen of the surface, and the surface will destroy it as a result of temperature, coefficient of temperature. And so we will combine kinetic and temperature interaction with the surface. So it's can apply for real purposes, for different scales. It's possible to treat the small particles and on even the big equipment, but just only outside of the surface, because inside pipes it's impossible to apply because it's very difficult to reach the surface. Laser, it's very modern methods of decontamination. It can apply for different materials and different surfaces. And methods of decontamination is cracks, just only cracks of surface. Also, like in the case of application of dry ice, as a result of very quick heating of this small area, and then very quick cooling of this surface. And so this, for example, here it is example of concrete surface, which can destruct as a result of very quick heating, cooling, and then just you will need just only collect the dust and aerosols. Now this methods are very applied in the metal industry for treatment of surface with very because the surface after this treatment will be with very good quality and very for example, this kind of laser treatment applied for construction of Russian design nuclear power plants in Bangladesh for treatment of metals fan for okay. So it is this method is very good, and so as a result of this treatment, you see this light microscopy before treatment and after treatment. You see it's very difficult composition of this layer and very corrosive layer
of the surface, but it's very clean surface after treatment. So this is main ideas what you need to have before you will choose the optimal methods for decontamination. We'll need to have all information about subject for treatment, about the final need, state of this subject for equipment or metal, for free release or for just only reducing of level of radioactive contaminations, for maybe the contamination for the surface for safety reasons, just only for possibilities to enter of personnel inside this contaminated room. So many purposes. You can create your decision-making process, and for different steps of this procedure, for different steps of decontamination or decommissioning of facility, you can apply different methods of decontamination. So it's also a list of different decontamination methods, just only for your information. We will not discuss. So I think we have time. Yeah, enough time. So
thank you very much. Yeah, yes.
Please, is laser technique suitable for large areas?
yes, it's possible.
How much large?
How much large? It depends on time you'd have.
Yes. Take lots of time because
For example,
beam is very
it's not small. For example, last week, my colleagues visited a facility for production of laser equipment for industrial purpose, not for Rosatom system. It's white of the beam. It's like this one, so it's a very quick motion. So for I think it's possible to treat maybe 1 square meter per few minutes. It's again, it depends on the level of contaminations. What's the contaminations of depth of penetration for this beam? So it depends.
Is the form technique is suitable for graphical surfaces?
Yes. Yes. You remember this picture when we applied it? Sorry. When we applied it for
yes, we can apply
glow box.
What about efficiency?
The same. Because it depends on time of collapse of form. You can prepare the different forms, which will, and so this time can be enough for time of treatment. It's a very different method. So very flexible method. You can apply different. You can add different additives for stabilization of this form. Some additives. Okay, chemical additives. Maybe.
Okay, and one more. What about the thermal technique for the purpose of decontamination?
Thermal? Well, it's a very difficult question because you understand that, for example, we last year in this to 2021 we completed research works. It's for our 12 company. It's melting of metals contaminated with transuranic contaminations. It's very good thermal methods for decontamination because in this case metals during the mixture of during the process of melting in induction fields it's treated with and contacted with special additives and in this case, practically all transuranic elements were removed from metal, and we need to storage or treat it just only small parts of slag, contaminated slag. For example, we had materials, metal with intermediate level, so low level wastes, but upper level of low level waste. But the slag was intermediate level waste because it was a very small amount, but metals was ready for free release after searching. So it's very efficient, but it's need to preparation of very special tools. Of course, it is not handy tools. Of course, it is a very big facility for industrial application with a very special system of gas treatment, and very special methods of very for long stabilization of in ignots. So many things. So it is very expensive methods, but very effective for metals contaminated with transuranium. Because if you remember the cost for storage of metals contaminated with transuranium materials, it's very high. Yes, long time. So it is the cost of space in the storage facility is very high, especially for intermediate level waste normally, because you might remember that alpha bearing waste has a smaller category.
And where can we find the comparison of the contamination factors for all this?
Sorry?
Where we can find maybe some table for decontamination factors for all these comparison?
Many publications, also EEA issued many publications in this area. OECD prepared a special edition of this. You have my email. Ask me, please, and maybe I will send you.
More questions? I have one actually. When people choose the technique, of course, it depends on the radionuclide inventory, on the type of surfaces, etc. But did they actually try some techniques before they choose finally what they should use? Some pre-testings, or how it works in reality, or they just believe that this method for this surface should work and
in our realities and for our company 12 is next. All the commissioning project has a few steps. The first steps is survey, radiation and engineering survey of the facility of some subject. Then preparing of decommissioning project. So this is very intelligent. People say, right, that all procedures which can ready for this, only for this facilities. And only next step is application of this, implementation of this project. So in the period of preparation of project, of this design project for this facility, professionals should be contact with, for us, with us, for example, with a team which have the knowledge about different methods, the advantages, disadvantages, possibilities to apply it. It's many factors influence for this process. So really, if you have just only needs for the contaminate a small room, it's don't need it. You can read this presentation and choose more applicable for the more expensive or cheap methods of treatment. But if you have a big project, when in this project, it's very important the cost of secondary radioactive waste, because you remember that price of the decommissioning project is maybe 60–70% is cost of treatment of radioactive waste, of management with radioactive waste. So in the big project, of course, reasonable to prepare the more difficult system for treatment. For example, for Bogunice VW reactor, the commissioning of Bogunice, and for Kozloduy NPP, we choose the different methods. For example, first of all, it is chemical methods because it's very flexible and very applicable for different contaminations, different materials. So it's more universal methods. But also includes the very good results is abrasive methods with steel pellets, application of steel pellets or dry ice. So it is a combination of few methods for this process. For big project, but this project, for example, Kozloduy nuclear power plant, it is 4 units. So it's thousands and thousands of cubic meters of radioactively contaminated materials. So it's reasonable. But if you have one room, or you don't need to install a special facility.
I have only one question. Is about a lot of techniques for diverse kinds of radioactive nuclides. However, there is only one radioactive nuclide big problem, which is tritium from water.
Which kind of?
Tritium.
Tritium, it's a very big problem. It's all problem. This is the biggest problem for Fukushima now.
Yes.
I think, yes.
They have about
It's very difficult.
500,000 cubic meters of contaminated water. So
Yes.
this issue, how to solve it?
But water, it is not decontaminated. It is treatment of water. So liquid,
Yes.
it is treatment of liquid radioactive waste. We discussed just on decontamination of surfaces. So, but really, of course, no. But of course, if you will have the surface contaminated with tritium, you will need to remove the upper layer of the surface. You will need to remove the upper layer of the surface. But if tritium will penetrate very deep inside metal, it will be a process of crash of metal, and it will incorporate between the minerals or structure of metals. You should be, it's just only melt, and melt it with very special additives. Or later treat all aerosols will be removed from after melting process. So anyway, it's a combination.
Or, yes.
Any more questions? It's not the case.
Thank you very much. Thank you.
So now we have a small break, and then it will be a practical exercise with the determination of the radio price. So.
die Entscheidung zum einen und natürlich, also die Entscheidung zu brechen, wobei das Ergebnis sehr komplex ist, wir brauchen komplexe Maschinen, das wird das Ganze wir haben die wir haben von Altbildung die Schutzfälle auswählen, einfache Technologie. Deswegen haben wir derjenige, der diese